Hello everyone and welcome to SimpliCode's YouTube channel. I hope you guys are doing well. Today, we'll be taking you through day 3 of this Java training program. I hope you guys must have understood all the topics from day 1 and day 2. It's very important to understand every concept from the previous days because the topics we are going to cover in today's video requires some extra bit of attention from you guys. So, I'll suggest you guys to go through them if you haven't watched that videos yet. We'll cover some new topics in today's video, but before we begin, I would like to take a quick confirmation from the viewers if we are clearly audible and the screen is clearly visible. If yes, kindly type yes in the chat section, and if there are any changes required from our end, please do let us know in the chat section. Alright, I see a lot of positive responses in the chat section, so let's wait for some more minutes so that some more people can join us. Until then, let me tell you guys that we have regular updates on multiple programming videos. So if you are a programmer and if you want to learn something new, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any updates from SimpliCode. Also, if you have any queries related to today's topics, please feel free to drop them down in the comment section only, and we'll address them as soon as possible. I think we can get started now. Let's go through the agenda for today's video. As I've already mentioned that the topics we are going to cover today needs a bit of extra attention from you guys. So, we'll start this video with classes in Java. Classes play a vital role in object-oriented programming. We'll cover some of the most important topics of object-oriented programming in Java, which are inheritance in Java, encapsulation, abstraction, and the concept of interfaces in Java. We'll move on and see how Java supports multiple inheritance, method overloading, and method overriding. Following that, we'll go through the concept of static keyword in Java. We'll then go through topics like packages in Java, recursion, method calling, exception handling, and try-catch in Java. We'll then cover some advanced level Java topics like hash code, comparable, comparator, enumeration, annotation, serialization, and threads in Java. We'll wrap up this video by going through synchronization in Java and autoboxing in Java. I hope you guys are ready to learn something new. Once again, I'm mentioning here about the Java Development Training Program, under which we'll be taking you through some important Java topics on each alternate day. So, this is day 3 and I hope to see you guys in the upcoming days as well. So without any further delay, let's get started. Over to our training expert.
Let's get started with classes and objects in Java. So like I have been promising in the previous sessions that I will cover this in a dedicated session, and this is the session where we will go deeper into the concept of classes and objects. You have been seeing this keyword all along in all the sessions wherever I ran the different examples, and let's understand what this means. Technically, if you go by the definition, a class is basically a blueprint of an object, which brings the question as what is object? An object is basically an instance of the class. I know this becomes more confusing, so let's break it down into simpler definitions. A class is technically a logical entity. You can think of it as any entity in the world. If you have to, let's say, if you have to build a student management system or a college management system, then all the real life objects which you see, we always say that Java is heavily inspired from real life examples, and classes and objects are the reason we say that, because whatever you see in the world is always basically some entity. Human beings are an entity, cars are an entity, students are an entity, lecturers are an entity. So all the actors which you see in the world are basically entities, and you can map them as classes in the Java program. Now, why do you want to map them? Because these entities have basically two kind of specifications. One is every entity will have some attributes and it will have some behavior. And actually that is how you identify an entity. For example, human beings have attributes like we have hands, we have eyes, we have ears, legs, etc. These are our attributes. Then we have our behaviors. Behaviors are actions. You can think of them as A human being can speak. So can speak is an action, it's a behavior. Can listen is an action, it's a behavior. Can walk is an action, is a behavior. Similarly, can eat is also an action or a behavior. So that's how you basically represent an entity. That's how basically you identify an entity, that an entity will have some attributes and some behavior. If you see those two specifications in any entity, you can map that entity, or you can write that entity inside a Java program as a class, because a class in Java will exactly have these two properties. It will have some attributes, which we call as properties, and it will have some behaviors, which technically are called as methods. So it will have attributes, and it will have properties and methods, similar to real world entity where we have attributes and behavior. Behavior are methods and attributes are properties. That's how it is. So if you apply this simple philosophy, whenever you are taking requirements from a customer for a particular project, always try to identify these entities, these actors in your program. Once you have identified those, you will be able to write a corresponding Java class in your Java program, which can represent those entities. And without representation of those entities, you cannot write the program. So Java will kind of force you to think in this direction, to find entities which will have attributes and behaviors. So taking that philosophy further and taking that example further, here for you, I have prepared an example where I am creating a student class. So basically, let's say if you have to build a college management system or a student management system, then student is probably one of the main entities which will be talked about when you take the requirements. So if you think about the attributes and the behavior concept, a student will have a name, will have an age, will have an address, and at the same time, a student can also have some behaviors, like can enroll in a particular course, can attend a lecture, can take a leave, can take exam, etc. These are all behaviors. Let's understand this in a more detail with the help of this example where I've created a class which is named a student. And you see the public keyword here. Again, I will cover access modifier. Public is basically an access modifier, and I will cover this in very detail in the upcoming sessions. For now, let's focus on this part. So we have created a class to represent our entity. You put a curly braces around it. It ends here. And after that, you provide the attributes. So here I'm saying that a student will have a name, it will have an age, and it will have an address. It has three properties. So the technical name of attributes is properties. After that, let's skip this part and I will come back to this part. Once you have declared these properties, you would want to provide a way for the name to be filled or replaced or received. For example, if you have created the student class, how do you insert the name inside the student class? Or how do you insert the age, or how do you insert the address or modify the age, name, or address properties? For that, we have these setters and getters methods. We call them setters and getters because they start with this keyword, not keyword, but they start with a string called set. It is not a keyword. You can actually write it as anything. You can call it as modify name. That will also be absolutely fine. Java will not give you an error. But the standard naming convention given by Java is to start the methods as starting with set and get. This is the standard naming convention. And like I said, it's a naming convention. It's not a compulsion. But if you write this way, your core developers and the people who are going to maintain this project in the longer run will be very happy. Otherwise, they will be very angry if you use strange methods, because like I said, this is the standard naming convention. So now you are going to write a setter method for each of the properties in this particular class for name, age, and address. So we call set name. Again, you put public void because this is not supposed to return anything. This is just supposed to set the value of name with whatever value you specified. Then you call set name, and then you provide the value which you are supposed to set against the name. So whatever value, like any random name, John or Jane, whatever, you need to supply that name here while you call this method. And that name, whatever name you supply, will be set against the name property of this particular class. And remember, I use the word this here intentionally because when you use this dot name, it is referring to the current object's name property. And this name is basically corresponding to the name which is coming in when somebody is trying to set a name. Similarly, for set age, age is a numeric number. If you observed, it's basically an integer. Then I'm saying int age, and whatever value of age will be coming will be set in this particular object's age. Then similarly, for set address, we have a string address argument being passed into this method, and this gets set inside the current object's address property. So I've provided a way for the external world to set the values of name, age, and address, because for each student, you would need to set these values. Now, you also need to provide a way to receive the values or to return the values or to read the values. For reading operation, you need to provide the getter method. So you see this get, again, this is not a keyword, it's a standard naming convention. So similar, when you wrote set name, similarly, you will write a get name method. This getName method is supposed to be reading the current object's name's properties value and will return that value. Since name is a string, that's why you see the return type as string here. Similarly, getAge is going to return the age, which is an integer, and address is going to return the address. You can also write it like this, which is absolutely fine. It is not going to complain because technically it is returning the current objects, name properties and age property and the address property. Now let's talk about this. What is this section? So this section is basically called a constructor, and I have a whole session dedicated on the constructors, but let's understand why we need this. Remember when I told you the definition of the class, I said that class is a blueprint of an object. So you have created a student class and you have 5,000 students in your college. Now you need to create a new student object for each of those students. You need to initialize this student class 5,000 times. How do you do that? To do that, we do that with the help of constructors. We call this constructor. This is a special type of method. Remember, this is a special type of method which is provided by Java to initialize any class's objects. If you want to create multiple objects of the student class, you can repeatedly call this student constructor. We call this constructor. So you put public here because we want this constructor to be accessible to the outside world. Then you put the exact class name. So whatever class name you have provided here, you need to put the exact class name here. If you don't do that, Java is going to raise an error. If I do this here, it is going to, you see a red line here because Java failed to compile this constructor. It does not understand what is student 111, but it does understand what is student. So this is how it is going to be. And then you provide all the properties which are going to create the student object. So you're going to create the name, the age, and the address. So the name, age, and address. And then you set those values again, similar to the setter methods we have seen. The reason we need to use this here because if you write it like this, then Java doesn't understand the difference between the current object's name and the name coming from the argument. So to differentiate that, you need to use this here. If you use n here, and if I just use n here, then this is fine because there's only single name variable in this whole class then. But if I write it like this, then Java doesn't know if this name is basically the student class's name or this name is student class's name. It will get confused, like you are getting confused if you try to just find this in the mind mapping. So that's why we need to write this here so that it's clearly differentiable that whenever I use this dot name, I'm referring to the class's name property. And when I'm just using the name, I'm referring to the method argument. That's what we do in this constructor. So you basically initialize all the properties of your class with some values with the help of constructor. So we have the constructor, we have the setter, we have the getter. We can cover about this toString. Basically, this toString is to print something, but we can cover that later. Now let's initialize this particular class. So I'm similar to the initialization we have seen so far. You just write student, you write the object name, this can be anything, and then you use the new keyword, which is used to initialize anything in Java. New is a keyword in Java, which you can use to initialize literally anything in Java. So you use new student, and when you say new student, you can provide all the values which should match its constructor. So here we have three values: string, integer, and string. And here also we are supplying three values: string, integer, and string again. So remember to match this exactly with one of the constructors which is available in the class. If it doesn't match, it is going to fail. It will not work. So if I, for example, if I do this, then I'm supplying 4 arguments to the student class, but there is no constructor matching 4 arguments, so it is going to complain. You see this red line and the code is not compiling. If I remove this, then it is matching it. And that's how you basically create a student object. So an object is basically an instance of the class. Remember that very well. An object is an instance of the class. Once you have created an instance of the class, then you can call any method, like say, let's say you want to read the name. So you can call get name. You can read the name. Similarly, if you want to if you want to read the age of the student, then you can do that as well. So let me just copy this and to this, let's call get age. I want to print the name, I want to print the age, and I also want to print the address. So get control space, I get suggestion address. Yep. So I'm printing the name, I'm printing the age, and I'm printing the address after I have initialized the object successfully by using this constructor representation using the new keyword. So now let's run this method or run this class basically. Okay, so when I ran this class, the whole class got compiled, the constructor, the getters and the setters and the properties and their types, everything was set. Then the main got called and I created a new object from this class's blueprint. The object name was John. Then I called john.getName to print the name which is stored inside this particular instance of the student class. Similarly, the age which is stored in this particular instance. So we stored the name as John. So when we call john.getName, we get John. When we call john.getAge, we get the age 25. And when we call john.getAddress, we get this particular address. Whatever values you specified here, the constructor got called here, and the name John got set to the student's name value. The age value which you supplied got set against the student's age, and the address value which you supplied got set against the student's address. And that's how you're going to create a class. So remember, whenever you create a class, identify the properties and the behaviors like setters and getters. Write a constructor which can cover all the values which you want to initialize. And after that, just initialize that class, create an object of that particular class basically. And once you have the object, then you can call getters. You can also call this in this way. If I don't supply any of this, then currently it complains. And why it complains, I will cover that in the following session when I will cover the multiple constructors concept. But remember, you see this behavior here that if you have created a constructor which accepts some arguments, and if you supply this kind of initialization, then student class does not have a constructor which is parameterless. Student class has only one constructor which is taking 3 parameters. And that's why Java complains, because it is not able to find a representation of a constructor which accepts no parameter. And let's get started with constructors in Java. Now, if you remember, we covered about the concept of classes and we walked us through with an example student class where we had a constructor. If I just open this back, this is the class which we covered in the last lecture. And we had this constructor where we supplied the necessary number of arguments which can match my student's properties. And then I set those properties calling this dot property equal to the argument like this. But what if you have a use case where some of the values are mandatory and some of the values are optional in these properties section? For example, what if all the students have same address? Although this is a very hypothetical situation, but let's assume if you have a scenario where you have a particular entity, you have identified the entity, but there are certain properties in the entity which remain constant for all the objects. If you have such case, then it does not make sense to supply an argument for that particular property which is going to remain the same for all the objects. What if you can just initialize it with some default values? That would be simpler, right? Because let's say, for example, if this property is going to remain constant for all the student objects, then you can just supply these 2 properties, these 2 arguments in your constructor, and you don't need to supply the address. Let's go further. What if you have a class where you have more than one property? Let's say if your class has 10 properties and 8 of them are remaining constant or are optional and only 2 are changing and mandatory. Then how would you write that? And what if you have a different use case for the same class? Let's make it even more complicated, that you have a single class. The same class or entity is being used by different consuming applications. One application would expect, let's say, these two to be mandatory and this one to be optional. Other consumer application wants these two to be mandatory and this one to be optional. The third consuming application wants all three to be mandatory. The fourth consuming application wants none of these to be mandatory. Then how are you going to do that? The answer is multiple constructors. You can write multiple constructors for each of those consuming applications, and whichever application wants whichever constructor, they can use that constructor to initialize the object of the class. So taking that concept further, I have created a class called cuboid, and I have three different properties written in this class. As we know that a cuboid has basically three properties, which are width, height, and depth. So I'm taking that example here, creating a class for a cuboid, providing the width, height, and depth. For simplicity, I'm taking this as integers, but generally you will see this as doubles probably because the values can be in decimal points. But for simplicity's sake, I'm just keeping everything as integer here. Then with a standard use case, if you have to create an object of this cuboid class, you would need a constructor where you can supply all these three values. And here it is. This is the constructor which can be called to provide these three values. So I'm supplying the width, I'm supplying the height, I'm supplying the depth, and then I am setting all of these values with this keyword, say this dot width equal to the coming width. This object's height will be the height which is coming from here, and this object's depth will be the depth which is coming from here. Now for another use case where, let's say, there's another consumer application where it would expect the depth to be constant for all of its objects, let's say a value 10, and it only wants width and height to be supplied. Then you can create another constructor. Java does allow the use of multiple constructors in the same class. Remember that concept. So you can create another constructor for that representation where you supply only the width and height and you keep the depth constant. Now, if a consumer application calls this constructor 100 times, all of those 100 cuboid objects will have the depth as 10 only. That will be the fixed value, and only width and height will be the changing values. Similarly, if there's another consumer application which wants to have the same height and width and depth for the cuboid, then it would just require a single parameter. Whatever value the consumer application is providing, you're setting the same value to the width, to the height, and to the depth. So technically, this is basically becoming a cube because then the three dimensions, the height, width, and depth are same. And what if you have another consumer application which does not intend to supply any of the values because for it, all the objects are going to hold the exact same values for all the properties. Let's say there's a consumer application which would always expect the width, the height, and the depth to be 10. Then you can create a constructor with no arguments. You can see there is no argument here. You can create a constructor like this, and you can supply all the default values, which are static values. So in this case, I have created 4 constructors. I have created this constructor here, which accepts all the values. And whenever you call this particular object, you will have to specify 3 values, and each object will have the width, height, and depth different. Second use case, where a consumer application wants the depth to be constant with the value 10 and only wants the width and height to be variable for each of the objects, then this particular constructor can be called. Similarly, for another consumer application which would want to just supply a single value, and it would want whatever value it supplies, it would want the height, the width, and the depth to be exactly the same as that value supplied, then it will supply only one value, and the same value is going to be set against height, depth, and width. And the fourth use case is where the consumer application does not intend to supply anything at all, but it would want the class to set some static values for all of its objects. So then it can call this constructor. And then I define a behavior. Remember the concept of behaviors. I define a behavior here. I have not defined the getters and setters here, but you can definitely do that. There's nothing stopping us from doing that. But for simplicity, I just skipped that here. Then I define a behavior to basically this class will provide a behavior which will be to create the calculate the volume based on the values which you supply. So whatever value you supply, based on that, the cuboid is going to calculate the volume. And as we know, the formula of volume is width into height into depth. That is how we are going to calculate the volume of a cuboid based on whatever values of width, height, and depth are supplied. So let's see this in action. I've created a public static void main method. I've initialized a variable called volume, which is an integer variable. We'll see how we can use that variable. And first, let's create a standard cuboid. So I call this particular constructor with 3 arguments. So when I do this, this particular constructor gets called, and the width, height, and depth values, which I supply here, 3 values, will get set, and I get a standard cuboid, and then I can call the standard cuboid dot volume. Then this particular method will be invoked, and the volume will be calculated with this formula with these values. That's how we're going to calculate the volume for a standard simple cuboid, and I'm printing that volume value exactly here. So this is basically the standard constructor being called with 3 arguments, calling the volume method, and then just printing the volume. Second use case where I'm calling the constructor with 2 arguments, and the third value should be set automatically. So I'm just supplying 2 values here. When I call the constructor with 2 values, a matching constructor should be found here with 2 values. Here it is. So width and height will be set with the values which I am supplying, and depth will automatically be set to 10. This is what is happening here, cuboid with some defaults. And then I again calculate the volume and print the volume. I'm just reusing the same volume variable here. In the third use case, I'm calling the constructor with a single parameter. So I'm just providing one value, and the same value should be set against all the width, height, and depth values. And technically it becomes a cube. So I've just called it as cube here. Then I'm calculating the volume of the cube and printing the volume of the cube. And then at last, I'm using the constructor with the new arguments. I'm calling this as default cuboid because I'm not supplying any values. And then I'm again calling the volume method on this and printing the volume. So these are the 4 constructor invocations. So this class is demonstrating 4 different kinds of constructor invocations. Let's run this class and observe the output. Okay, so let's start from here. I called this particular constructor with 3 arguments, 10, 20, and 15. And then the volume was calculated, which would be 10 into 20 into 15, which is 3000. So this sysout basically prints this output. Then move on to the next one, where I'm saying cuboid with defaults, which is having the value 10 and 20. And the third value of depth is automatically being set to 10. So technically, when I call the volume, it will become 10 into 10 into 20, which is 2000. And that's how the volume of the cuboid with default depth is printed from the line 47. Going on to the next one at line 51, the volume of the cube is basically the volume which is calculated after calling this particular constructor and calling the volume method. So here the height, the width, and the depth, all 3 are set to 10. So it will technically be, when we call the volume method, it will be 10 into 10 into 10, which is 1000. And that's how you get this output, which says volume of the cube is 1000. And then I call the default cuboid method, which is simply providing no values, and we expect everything to be set with some defaults. And the default constructor is setting the value as 10 for height, width, and depth. So in this case, if I'm calling the volume method and if I'm printing the volume, it should be printed as 1000 because 10 into 10 into 10 is 1000. So this is basically to showcase you how you can use different constructors. There's another thing which you should know is if you do not provide any constructor to this particular class. Let me just comment out all the constructors in this class. And let me comment out most of the code here as well. So now if you see, I have not provided any constructor in this particular class, right? There's no constructor. Let me just maximize this. So there's no constructor being called here. There's no constructor being left here. Everything is commented. So there's no constructor in this class, but this line still passes. There's no compilation error. There is no red line on this particular line. The reason is if you do not provide a constructor to a class, Java by default will provide a constructor, which will be the no parameter constructor. So remember that whenever you don't supply any constructor, you can still create objects of that class with this non-parameterized constructor representation, like student equal to new student without any parameters. That will work if you have not provided any constructor implementation inside your class. And if we do that, let's see what value do we get, because I have commented the default constructor, everything here, right? So let's print the value. If I go to run as, I get the value as 0. So what happened here? When I call this particular line, the default constructor provided by Java gets called, and Java will set the values of all the properties to the default values which are supported by the data type. And integer primitive data type's default value in Java is 0. If you do not if you do not assign a value to an integer variable, by default it is going to be initialized with 0. That's the Java's behavior. And that's what is happening here because we did not provided a default constructor. So when we call this new cuboid here without any parameters, without any arguments, the default constructor of Java gets called and it sets everything with the default values, which is 0, 0, 0. And then if we call the volume method, it's basically 0 multiplied by 0 multiplied by 0, which will eventually be the output as 0. And that's how you get this 0 output. Let's try one more thing. What if I enable one constructor? Let's enable any one constructor, which is having at least one parameter. Let's say this one. So I have enabled one constructor. I've just removed the comments from one constructor, which takes a single argument. And let's go down. Now you see an error. So this is something, again, a Java's behavior, that if you provide even a single constructor in your class, which is having at least one parameter. I'll just repeat that. If you create any constructor in your class which is having at least one parameter, then the default constructor implementation of Java will not automatically work. In this case, you will have to explicitly provide a default constructor as well. The default constructor will only and only work if you have not provided any constructor at all in your class. The moment you provide even a single constructor which is having even a single parameter in your class, then the default constructor out of the box will not work and you will have to explicitly provide a default constructor. So to make this work, I have to just enable the default constructor code and then only it will pass. So if no constructor, it will work without any parameter. But the moment you provide even a single constructor with even a single argument, then you have to either use that parameterized constructor or you have to provide your own default constructor implementation, because Java will not use its own default constructor implementation in that class. So I hope you find this particular concept useful, and remember this concept because this is, again, this can be confusing when you are reading somebody else's code. You need to always understand what all constructors are there. And let's get started with access modifiers in Java. So when we talk about access modifiers, let's understand what is the underlying philosophy of the reasoning behind this. And the reasoning is very straightforward. It can be even wrapped into a single word, which is called security. The reason is that you will be creating multiple kinds of objects and variables while you write your Java program. And you should always write your Java program or any program in a manner that only the intended classes, packages, modules, or applications should be able to see what they are supposed to see. So as a consumer application, I should only be able to consume the variables which I am expected to consume. I should not get any variable, or I should not even have access to any variable which I am not supposed to access. So the idea is providing the least privilege principle. Give access to different functions, different variables, different programs only by providing them the kind of access which they need to run efficiently, and do not give them complete access. So with that notion in mind, Java created the concept of access modifiers, and it created these three modifiers, which are called public, protected, and private. If you do not provide any modifier, then it goes to no modifier, or some people also call it as default modifier, which is also a type of access modifier. So let's understand theoretically first how it works, and then we will try to have a look at an example. Let's understand the first one. First of all, these modifiers are keywords, and you can use these keywords in front of classes, in front of variables, and also in front of methods. And you might have already noticed this particular keyword called public in front of all the classes I've created, or even when we talked about the public static void main method, we saw this public as a keyword. It is basically an access modifier. And whenever you put public in front of a class or a variable or a method, that particular component becomes available to the whole of the program. It will be available to the whole world, basically. any subclass or any package or any other class which might have been written in your Java program will be able to access that particular class or variable or method if you put public in front of that. The second modifier level is protected. One of the other thing which you will understand as I explain this is that as you move down into this particular table, the access level will start getting more and more restricted. And by restriction, I mean that less and less components will be able to get access to those modifiers. So if you write protected in front of a class or in front of a method or in front of a variable, then everything within that particular class will still be able to access it. Everything within the package will still be able to access it. I still haven't covered the concept of package, but I briefly touched upon it, showing you how whenever we write a class, we have a package in front of it, and package is technically is just an aggregation of the classes. If you have to write multiple classes and wrap all of those classes into a single logical bundle, that would be called a package. Just to show you an example, these all are packages which you see here. You see this square box here, and you see these names, these all are packages. And these packages contain multiple classes. And technically, that's all the packages mean, that you can wrap multiple related classes into a single package. So coming back to the access modifier, whenever you write protected in front of a class or a variable or a method, then that particular component will be accessible to everybody within the same class, everybody within the same package. It will also be accessible to everybody which is a subclass of the class. This is again a new concept which I have not covered, but this basically means a child of this class. Now, what is a child of the class? We will cover that concept in detail when we will talk about inheritance. But for now, you can understand that it is basically an extension of the class. So when the moment you declare something as protected, it can easily be accessible within the same class in which this protected component was declared. It can be accessed in the package. It can also be accessed in the subclasses of the class, but anything outside the package will not be able to access it because you see an N here. Then we have the default access modifier or no modifier. If you do not write anything in front of a class or a method or a variable, it gets the default access modifier privileges. And that privilege means that anybody within the same class will be able to access that default variable or a default component. Anybody within the package will also be able to access it. The subclasses of the class where the default component was declared, those subclasses will not be able to access it. And anybody outside the package will obviously not be able to access it. Then comes the last one, which is the most restricted privilege, which is called private. So if you put private in front of a class or in front of a method or in front of a variable, that component will only be accessible within the class where it was declared. It will not be accessible in the package. It will not be accessible in the subclasses and definitely not be accessible to anybody outside the package. So private is the least privileged or least access permission level you have in Java. Once you write private in front of any component, that only the classes, other variables, the same class in which you declare this particular private variable, only that class itself will be able to access it and nobody else will be able to access it. And as you move above, the accesses become more and more lenient. You can see there's just one Y and 3 N here. The moment you move a bit above to the default modifier, you get 2 Ys. So everybody in the class and everybody in the package will be able to access that particular component. For the rest of the other world, it is still unknown. When you write something as protected, then everything in the class, everything in the package, and everything in the subclasses will also be able to access it. Rest of the world cannot access it. And if you write something as public, then anybody can access it. It's like Y everywhere. So that is how the access levels work. Now let us understand this with the help of example. So I will go here and I've just written a very simple dummy class here, which is a class called test. And I have a method here, which is a display method. So very simple class, nothing fancy here. And if you notice, I have not put any kind of public, private, or protected modifier in front of the class. So this will get the default privilege. If something has default privilege, then the whole world will not be able to access it. So let's go to a different package. Let's go to this package, which is here. And let's try to access this particular test class. So we will try to access this test.java here in the main class. So let's try to do that. Let's say test t equal to new test. I'm just initializing the same class. So what do I get? I get a compile error. Let me try to fix it if I can, and I cannot fix it. If you see, I'm just trying to use this particular test class into a different package, but that package is not able to see the class at all. I'm getting a compilation error, and if I try to click on the error, generally Eclipse provide me suggestions to import this particular class. But Eclipse is not able to find any class with the name of test, which can be imported in this package, which is a different package than the one of the test class. So we cannot access it because it's in the default access. Now let's go back to the test class and let's make it public. So I've just made it public here. And now if I click on this again, I get the suggestion. If you see, this suggestion was not there earlier. Now it says import test. And if I click on this, double click, it gets imported and everything is happy. So you can see the whole access modifier in effect here, the default versus public. You can also try the other kind of access modifiers. Let's try private as well. I think private will also have the same effect because it will still not be accessible from the package or from the subclass or from the whole world. We already saw this particular in effect, but we'll see the private in a different way now. So going back to the test class, I've made the class as public, but the method here is default. I've not exposed this method to be used outside the class. Let's see what happens if I try to call this display method from the main class. So I have successfully initialized the class, and if I say t dot, and if I look at the suggestions here, I do not get the suggestion of the display method. Why? Because it is default. If I go back, make it private, can I now access it? Let's try again. Nope, still we can't access it. Eclipse is not even able to find it inside this package because it is private. Let's go back and make it public. So I've made it just public now. Going back to the main class and again saying t dot, now I get the display suggestion as the first suggested method here. And now I am able to use the display method once I have made it public. So you see, the moment you change the access modifiers, the changes are propagated immediately. And you can see the public versus default versus private in play here. We can even go into further detail by using the protected, but for protected, I have to explain the concept of subclasses. So I will cover this protected versus subclasses concept when I talk about inheritance, and there we will see the usage of protected variables and the protected access modifier. But we saw the usage of public, the default modifier, and the private modifier. Do check out the documentation for these access modifiers, and I would strongly suggest you to play around with this, get more comfortable with this concept of different kind of modifiers. Let's also run an example for understanding the default modifier in a better sense, because we can see that for the package, it says y, right? So let's go back to Eclipse, and within the same package where we created test class, let's create another class. Let's call it test demo. So I will just click finish. I get a new class. Let me also write the public static void main method here. So I get the public static void main method here, and let's try to access the test class here within the same package. So let me again go back to the default privilege here. So I put the test class access as the default class or default access, and same goes for display. So can other classes in the same package access the test class now? Let's see that. If I go to test demo, and here if I try to get the test class initialize, does it work or does it give me a compilation error? Yes, it works. It works because the test class and the test demo are in the same package, and test class has the default access privilege. So let's try to run one more variation of it to understand the usage of the private method better. Going back to the test class, this display method has the default privilege right now. So going by that logic, if I say t dot, I should be able to get access to the display method. And yes, that is possible. If I run this particular program, I will be able to get whatever is given out by the display method, which is hello world. Now let's try to make this particular method as private. And let's try to access this method from one of the other class in the same package as of the test class. So the class is default, the method is private. And if you see, this class has already turned red. There is a compilation error because now the display method is not accessible to the test demo class. Even if it was in the same package, it's not accessible because the display method's privilege or access modifier has gone to private now. exactly the same as explained here. Because it has become private, so the package level members cannot access it. There's an N here. So this was another variation to show you how you can use public, protected, and private together to only expose the members, methods, and classes which are supposed to be exposed to the consumer. This is a very critical and very important concept to be used in Java, and it is used from a very simple program to all the highly complex application. This is sort of the bare bone or the laying foundation for any kind of basic security level premise which you need to build in an application. Let's get started with inheritance. So inheritance is basically one of the most important properties of any object-oriented programming language. It's basically a concept, and the concept says that what if you have a scenario where you want multiple classes to share similar behavior and similar properties. Let's understand this with the help of an example. Let's take the example of a bank. When you go to a bank to open an account, there are multiple types of accounts. There can be a savings account. It can be a type of current account. There can also be a different offering for personal account and commercial accounts, such as for businesses. Then you may also have loan accounts, which are having different kind of properties. So all of these types of accounts are still technically accounts, and they will share some similar properties. For example, all of them will have to maintain some sort of an interest rate. For example, all of them will be used to either deposit money or withdraw money. So there would be some kind of similarity across all of these types of account classes. But at the same time, there will also be some sort of differentiality amongst these classes. The way you will calculate the interest rate for a current account will be different from the way you will calculate the interest rate for a savings account. And the same applies for commercial account, personal account, loan account, etc. So you see that we have some common behavior, but at the same time, we also have some different behavior. So whenever you have such scenario, always think about applying the concept of inheritance in your application. There's another simple way to spot whether inheritance can be used at a particular place or not. Inheritance is also called is a relationship. So whenever you read the requirements from a customer, just try to find the words which use this particular phrase is a. For example, car is a vehicle. Savings account is a type of account. Similarly, you will find many other types of similar examples. So whenever you will see that is a relationship between two different kinds of objects or two different kind of entities, that means that there might be an inheritance relationship being applied between them. And that's how you will spot the usage of inheritance. So far we have understood this concept that there would be some sort of relationship between the two classes. What will be this relationship? The relationship will be of parent-child type. There will be a parent class. Some people also call that as base class. And then there will be a child class. So the child class will be inheriting the properties and the behaviors from the base class or from the parent class. I will be using base class and parent class terms interchangeably during this session. But the basic idea and basic premise is like that only, that there will be a child class and there will be a parent class. And the child class is extending from the parents class. Remember the word extend because we are going to use that. And I've just shown you the what you see here is basically the official definition, which is given by Java docs here. We can read the definition as well. And the basic idea which I told you lies in the parent and child relationship. And this is how you can conceptualize it, that you will have a base class or a parent class, and then you can have multiple children of it. And then those children can again have their own children, and so on and so forth. So this hierarchy, this whole inheritance hierarchy, can go as deep as you want it to be. And that's the basic idea and basic conceptualization of how you understand and how you visualize inheritance. Now let's move to Eclipse IDE and try to understand this with the help of an example. So for this particular case, I have created a set of classes basically, which we will be using to demonstrate the relationship of inheritance. And I've taken the simple example of a bicycle. So a bicycle is again a very generic definition of any two-wheeler, and bicycles can have multiple types. There can be an all-terrain bike, there can be a mountain bike, there can be a city bike, there can be a bike which is specifically made for ladies, and similarly there can be multiple different types of bikes. But all of these bikes will have some similar properties. For example, all of them will have two wheels. all of them will have a seat, all of them will have brake, all of them will have some sort of a speeding mechanism, whether they can accelerate or deaccelerate. So there will be some commonality, but at the same time, a mountain bike's features might be very different from a city bike feature. A mountain bike mountain bike might have gears, for example, whereas a city bike might not have gears, because you don't need that much of a variation in inclination and declination when you drive down the road. So I'm trying to conceptualize the same example here, where I've created a class called bicycle, and this is my base class. I define two properties in the bicycle class, which is gear and speed. We will come back to protected in a while, but let's leave that there. So I have two properties, which is gear and speed. I have a constructor where I'm initializing the starting speed and the starting gear. And then I have three methods here, which says set gear, apply brake, and speed up. When I apply brake, the speed is going to get reduced. So that's why you see minus equal to unary operator. And when I'm trying to speed up, the speed is going to increase. That's why I'm using the plus equal to unary operator. So when you use the method speed up, the speed is going to be increased by the value you supply in the method. Similarly, when you apply the brake, the speed is going to get reduced by the amount you supply in the method argument. And that is my base class: bicycle, gear, speed, and three methods. Now let's have a look at the child class. So the way you will define the inheritance relationship in Java is by using this extends keyword. Remember, I told you to remember the extends keyword. So what you will do, that you will write your class name as usual, and then you will use extends keyword, and then you will use the parent class name or the base class name. So here I'm saying class mountain bike extends bicycle. And here I'm providing an additional property. Remember the whole commonality versus differentiality equation. So a mountain bike might have an extra property to adjust the seat height. So that's the extra property which mountain bike is having. And then, since this mountain bike is extending the bicycle class, this mountain bike class has the responsibility to initialize the bicycle class as well. And the way it will fulfill that responsibility is by taking all the arguments of bicycle class plus the mountain bike class in its constructor. And that's why you see three different properties here. You see the start height property, which is the property of this particular class, which is the seat height. And then you see the start speed and start gear property, which directly are not available in this class, but this class is inheriting those properties from the base class. Remember the keyword inheritance here. And then once you do that, how do you initialize the base class constructor? Is by calling the super method. This is again a keyword in Java, and you will use this super keyword to refer to the base class constructor in this way. So what you will do technically is that you will write super and you will supply the arguments which is required by the base class constructor. If I go back, the base class constructor requires two arguments, start speed and start gear. So I write super and then I write start speed and start gear. So whatever I got from here in the constructor of mountain bike, I'm supplying those values as is to super. And Java will automatically take care of invoking this particular constructor the moment it encounters this kind of statement. Another thing to notice is that the super keyword or super statement has to be the first statement inside your constructor. Remember that whenever you are dealing with inheritance and whenever you have to initialize the super class constructor or the base class constructor, use the super constructor invocation as the very first statement inside your child class constructor. Otherwise, Java will not compile the program. And then you will initialize the local variable. I should call this as this. Remember, we discussed about this in the classes session. Okay, and then it just has a method of set height. So there's no extra method which this mountain bike is providing, but this mountain bike will have access to all the methods which have been provided here and all the properties which have been provided here. This mountain bike can access everything from the bicycle class. And that's the whole idea of inheritance, that the child class can access the properties of the base class by extending the base class. Now let's look at how do we invoke this particular class. So for that, I have a simple class name as inheritance demo, which has a public static void main method. And then I am initializing the mountain bike class. I'm supplying three values as 20, 10, and 1. So the 20 goes to start height, the 10 here goes to start speed, and 1 here goes to gear or the start gear. And that's how I'm setting the values. So when I call this particular constructor here, the mountain bike constructor is going to, this mountain bike constructor is going to get called, and which in turn is going to call the base class bicycle class constructor as well, and everything will be set accordingly. And then let's try to access the gear property. Remember, gear is not directly available in the mountain bike class, but I'm still able to do mountain bike.gear because child class can access the parents class properties. Similarly, the same thing goes for speed as well. And seat height is the local property of this particular class, mountain bike. So it will anyways be accessible. So I can access all the properties of the base class and the child class itself seamlessly without any differentiation. Now let's try to call a method. So here I'm calling the method apply break. Remember, apply break was defined in the base class, not in the child class. It's defined here. So I'm calling the apply break method, and I want to reduce the speed, the current speed by 1. And then I'm printing the current speed, saying that bike speed after applying break is mountain bike dot speed. So let's run this particular program and observe the outputs. Okay, so the first statement which gets printed is at line number 7, which says gear is 1 because it's coming from here. Then the seat height is mountain bike dot seat height, which is 20, which is the first argument here. And then the bike speed is 10, which is coming as here and getting printed here. And then when I apply the brake, let's go back to the apply brake method. The logic is that whatever is the current speed, reduce it by the value I supply in the method. So if I supply 1, 10 minus 1 becomes 9, and that becomes the current speed. If I supply 5 here, the current speed will be 10 minus 5 equal to 5. Let's assert that particular assumption as well. Yes, we can see that. And similarly, you can access other methods of the base class as well. If I just do control space here, and you can see apply brake is accessible, set gear, set height, speed up, all the methods which are defined in the base class are accessible in the child class as well. This is the power of inheritance. One more thing which I said I will come back to is around the usage of protected access modifier. Remember when we discussed about the access modifiers in the previous session, I said that protected is used when you are dealing with inheritance, that whenever you define something as protected, it will be available to be accessible in the child classes of the base class. So if I define this particular variable as protected, then this particular property will be accessible in the child class mountain bike as well. Let's play around this. Let's make this as private and see what happens. So if I make this private, now when I say private, the scope of this particular variable is within the class only, and nobody outside the class will be able to see it. And you can see the effect of it. I can see an error being coming here in my inheritance demo class because now mountain bike object cannot access the gear property because the gear property is defined in the base class and now it is private. That's why the child class now, mountain bike class, cannot access the property gear. And the moment you make it back to protected, it will be accessible. The error is gone. There's no red line here. So that's how you can use the protected access modifiers. It is always recommended to use them when you write any kind of inheritance logic. And in inheritance logic as well, intentionally, if you want to hide a particular property from the child classes, just make it private. And let's get started with today's topic, which is about encapsulation. So again, let's understand what is encapsulation in general, and then we will apply that concept to Java. Encapsulation, if you try to break that word, if I just write it here in the form of a comment, it's encapsulation. Just trying to break this word into to make it more visual. So you see a word called capsule here. So if you try to imagine a capsule, why do you create that, and what's the concept of a capsule? Capsule tries to pack a lot of things inside a small tube-like shape. And the concept of encapsulation is sort of inspired from that. Not exactly, not literally, but that's the basic idea of this root word, which is called encapsulation. So encapsulation basically means to restrict accessing the properties of a class to the outside world. if you want to protect the properties of your class, how do you do that? You do that with the help of the concept called encapsulation. So here this is a sort of a security feature. You can think of it as a security feature that you want to protect the properties of your class, and you will use encapsulation to protect the properties. How you implement encapsulation? Let's have a look at that now. So basic idea is to encapsulate the objects, create sort of a capsule around the object which can provide that protection layer. And you will define how the outside world is going to access the properties of the class if needed. So I've created a simple class here, and it's if you remember one of the previous examples when we discussed about classes, I used the same class, which was the student class, and I'm just using the same class for continuity. So I've created a student class here, and I have created three different properties of this particular class, which is name, name of the student, age of the student, and address of the student. You see, intentionally, I have used the keyword private in front of these three properties. And that is the first thing which you need to do to implement encapsulation on your object, that you hide all the properties from the outside world. Remember, the moment you make anything as private, only the class, which is the student class itself, only the class itself can see these variables or these properties. Nothing outside the student class will be able to access the name or age or the address directly from the student class. It's not possible. That's the whole idea of making it private, because you don't want the outside world to access these properties. So you make those properties as private. Then you create a constructor. The constructor has to be public so that anybody can initialize the student object, because you want your object to be accessible. Remember, so you want the objects to be accessible, but you want the restriction on the access of the properties of the object. And these are the properties of the object. So you have restricted them by making it private, but that doesn't solve the problem, because there will be some illegitimate consumers of the student object which should not have access to the student properties, but there will also be some legitimate consumers of the student object which should be having access to the properties of the student. For example, the payroll application will need access to these particular properties. The examination application will require access to these particular properties. So how do you do that? You create getters. We call them getters because they start with the keyword get. So you create a getter method for each of the property. You create the method called as get name, and this is the naming convention which Java promotes, that you write get and then you write the name of the property in camel case. So you write get name, and this property is supposed to return the name property of this particular object. And here you say return name. So you're returning the name which is being stored by the current student object whenever somebody calls student object dot get name. And this is the way you have restricted the access of this particular object as well. So remember, you made it private so that nobody can access it. And then you defined your own way of providing access to the name property of this particular class. Now, if anybody wants to access the name value of your student object, there's only one way to do that, which is via calling get name. So you have provided restrictions, and you have also provided prescriptive guidance on how you are going to expose the properties of your class. That's the second thing which you need to do to implement correct form of encapsulation on your object. That is to provide the getter methods with the right visibility. You want to make them public so that anybody can call them, but since you are governing which is what is written inside the method, you have full control on what kind of exposure you want to give for this particular property. Similarly, you create a getter for age, calling get age, which returns the age, and then you call you write get address and return the address. Here it is simply returning it, but if you want to do more stuff here, feel free to do that. Like I said, you govern the control of how do you want to return the name. Maybe you don't want to return the complete name and you want to just return the initials. Then you can split the string, trim the string, and return only the initials. So that's the basic idea of getters. Now, after you have created the object, there might be use cases where somebody needs to overwrite the values of the properties like name, age, or address. What if a student's name was incorrectly mentioned when they called the constructor and now they want to overwrite the name or fix the name? So basically, they have to replace the existing value of the name with a new name. So in that case, you need to provide what we call as setters. And they start with set, that's why we call them setters. And we follow the same kind of logic that you provide the setters for all the properties of your class. So you had three properties, which were name, age, and address, and you provided the setters for all three of them. And how do you provide that? You again make them as public because you want the outside world to access this setter method to override the values of the name. This method is not going to return anything, so it is going to be void. Then you write the name of the method, which starts with set, and then the property name in camel case. And then you provide the new value, which is the value which should be the new value, and this is the value which should replace the existing value. So whatever new value you want to supply, you supply that as the argument of the setter methods for set name, for set age, or for set address. And then you write this particular line, which says set the current name property of this particular object with the name which is coming in from the argument. So this dot name, remember, this dot name represents the current object's property because this represents the current object. So whatever is the current object property value of the name is, just override that value with the argument coming in. Do the same thing for age in set age method, and do the same thing for set address in the set address method. So this is how you are going to provide the setters and the getters. So setters and getters can also be generated in smart IDEs like Eclipse. So you just right click, you go to source, and here you will see the option of generate getters and setters. If you click on this, it will give you the list of the fields which are available to be having getters and setters. Currently, it says no fields or all fields have getters and setters already. Yes, because they have it. Let me just comment this and show this how this works. So for example, let me comment all the getters and setters. So I'm commenting them. And if I right click, source, generate getters and setters, I get all the fields available for which setters and getters can be generated. So you can select them and leave everything as default, hit generate. And it is automatically going to generate the getter and the setter. You see, all the code of the getter and setter is automatically generated. You do not even need to write it. And this is the power of the smart IDEs. Let me just revert what I did. So you created everything as all the properties as private, and then you define how you want to replace the values by providing the setters, and you define how you want the outside world to access your properties. So you have full control of the class now. You control the visibility, you control how they are going to get initialized, you are controlling how the properties are going to be overwritten or set, and you control how the properties are going to be returned. So you have complete control of the class. So you have created a perfect capsule here, a perfect form of encapsulation in this class. And this is how you can implement encapsulation. And let's get started with abstraction. Let's first understand the definition of abstraction before we relate this to Java. Abstraction generally means hiding something. When you want to hide some details of a particular object from the outside world, you apply the concept of abstraction. For example, when you drive a particular car, you just hit the accelerator and the car speeds up. Now, it's not only one action. When you hit the accelerator, the whole machinery of the car and all the components, different parts of the car work together to speed up. There would be engine, there would be propulsion, there would be fuel, there might be some, if it's an electric car, there would be batteries, there would be whole different kinds of pistons and plugs which will make the car speed up. It's not only a single component, it's a lot of different components under the hood. And that's the concept of abstraction, that we only show the relevant parts to the user and we hide all the internal details from the user. That's the basic idea of abstraction. So a car manufacturer abstracts away all the inner technical details from the driver and just gives the driver a single pedal to speed up the car. For a user, it's a very good experience because he doesn't need to know about all the internals of the car. but the car manufacturer can hide all the details and provide a very simple interface for the driver to interact with, which is just a gas pedal. And that's the basic idea of abstraction. And we try to apply the same kind of concept to Java in the form of abstraction. And Java provides this kind of concept implementation with the help of a keyword which is called abstract. Now, abstract is a keyword which can be used in front of a class or a method. When you use it in front of a class, the whole class becomes abstract. Abstract class is a type of class. So the class itself becomes an abstract class. One of the things to remember is that abstract class cannot be instantiated, but can be subclassed. Remember, we talked about the concept of subclass and the parent class when we talked about inheritance. So if you make a class as abstract class, you cannot call the constructor of the class because you cannot instantiate it, but you can extend the abstract class and create a child class out of it. That's the concept of abstract class. Another concept is abstract method. You can also use the abstract keyword in front of a method. And when you use abstract keyword in front of a method, then that method is only declared without an implementation. You are not going to provide any implementation of the method, and you're just going to declare the method. Something like this. We will see a similar example in the hands-on as well. But that's the basic idea, that you just declare the method. You are not providing an implementation as to what does move to method actually does, because that's the whole concept of abstraction. And it is the responsibility of the child classes which inherit the particular class in which the abstract method would be sitting. So that child class will be having the responsibility to provide a concrete implementation of the declared method. Let's understand this better with the help of an example. So here I have created a class called graphic object, and I have made the class as abstract class. This is the keyword which you need to use in front before the class keyword, and the class becomes an abstract class. Now, when you create an abstract class, it automatically gets some properties. The first property is that this particular class must have at least one abstract method. And this is how you define the abstract methods, where you just provide the declaration, but you do not provide the implementation of the draw method or the resize method. And the way you will create the abstract methods is by using the abstract keyword before the actual method declaration starts. So general method declaration would look like this. And if you use abstract in front of it, this becomes an abstract method declaration. Abstract class can also have concrete methods. So that is the liberty which abstract class gives you, that you can have abstract methods which are just declared, but you can also have normal methods which are where you can also provide the implementation. So you can have normal methods and abstract methods as well in an abstract class. So this is the abstract class. Now, if you want to provide an implementation of the draw and resize method, you have to extend this abstract class. So we extend this abstract class by creating two child classes out of this particular abstract class, which is circle.java, where you can see I create a normal class and I use the extends keyword for inheritance. And I'm saying that circle class is inheriting from the graphic object class, which was my abstract class. And once I use this extends keyword, then I have the responsibility of providing the implementation of the abstract methods. Actually, Java will force me to provide the implementation of these two methods. If I do not provide all the declared methods, so there are two declared methods here. So if the circle class does not provide the implementation for both draw and resize methods, then Java will throw an error and it will ask you to take an action which can be either define all the methods, meaning provide implementation for all the methods, or make the circle class itself as abstract. Let's see, if I just comment this particular out, I get an error. You see a red line here. And if you click on this particular balloon here, it will say either you can add the unimplemented methods or you can make the circle type as abstract. So these are the two options which you will get to fix this particular error. So an abstract class can be extended by another abstract class if the child abstract class is not implementing all the methods of the parent. If you want to implement all the methods, then just implement them and keep it as a normal class. And that's what I've done here. I've just created a normal class here and provided the implementation. And once you provide the implementation of both of the methods, the error is gone. Similarly, I've also provided another child class because it's there can be multiple children of a particular parent. So rectangle also extends from the graphic object, and it also provides its own implementation of drawing and resize. Because generally the way you will draw a rectangle and you resize a rectangle will be different than drawing or resizing a circle. Here I'm not doing anything in the methods because this is just to show you the demonstration. I'm just printing a sys out saying drawing a circle and resizing drawing a rectangle and resizing a rectangle, and in the circle class, drawing a circle and resizing a circle. So one abstract class as the parent class, which is the graphic object, and two children, circle and rectangle, both providing the implementation of the abstract methods which were declared in the base class. Now let's go to the main class, where I've defined the public static void main method. And here you see I have created two different kind of blocks of code here. One block is where I'm saying graphic object, creating a reference of the graphic object named as circle, and initializing the circle object. Now you see a difference here. Here is the abstract class and here is the concrete class. So whatever you define on the right hand side, whatever is the type of object will be the type of methods being called. So if you created a circle object and then if you call the draw method and resize method, these methods will be called from the circle class. If you initialized it as new rectangle, then you are creating a rectangle class object, and then the draw and the resize method will be called from the rectangle class. That's the basic construct, and that's how you will initialize a particular class which is using an abstract class. So I call graphic object circle, new circle, and I call circle.draw and circle.resize. Similarly, graphic object rectangle equal to new rectangle and rectangle.draw, rectangle.resize. Let's run this program and observe the output. So when I call this particular block of code, circle object gets initialized, and then circle.draw method prints drawing a circle, and circle.resize method prints resizing a circle. Similarly, when I create the rectangle class object, referencing it with the graphic object class, rectangle.draw prints this particular line, drawing a rectangle, and rectangle.resize prints this particular line, which is resizing a rectangle. And this is how you will use the concept of abstraction. There's another very interesting thing which is going on here. Remember, I told you that the abstract classes cannot be instantiated. So if I go here and I try to create a constructor of the graphic object class, let's see what happens. If I do this and I just put a system out here, base abstract class. So if I do this here, if I still write a constructor, though Java says that it cannot be instantiated, if I still write a constructor of it and I do not do any changes here, and if I run this particular program, let's see what happens. You'll see the base abstract class being called here. Let me just reformat it by putting ln here so that we get a better output. So if I run this particular program, you see base abstract class is getting printed somehow, though we said that abstract classes cannot be instantiated, but still the constructor of this is still getting called somehow. When I create a circle class, the base class constructor gets called, and when I create a rectangle class, again the base class constructor gets called. This is the power of inheritance, because in inheritance, remember how it works. When you initialize a particular child object, referencing it with the parent object, see the reference is of the parent class and the object is of the child class. So whenever you do it like this, first the default constructor, because I'm calling the default constructor here, the default constructor of the circle class will get called, which will go here. Remember, I told you that Java provides the default constructor automatically if you don't provide it. So the default constructor of circle gets called, but Java sees that you are writing this code here, which says circle extends graphic object. So Java is automatically going to call the parent class and going to initialize the parent class as well, because that's how it will be able to see these methods. And so that's why it will automatically call the base class constructor, even if you don't call it explicitly. In fact, you cannot call it explicitly. Java will not allow you to initialize the graphic object class explicitly. It can only and only be called by Java itself indirectly via the concept of inheritance. If you try to do this, let's try to do this for fun and also for better understanding. So if I write graphic object go equal to new graphic object, you see I don't even get an option, but let's write it and let's see what happens. So you see that it gives basically an error because it's not able to find the constructor of the graphic object class. Though even I have defined the default constructor here, but still Java is not able to find it because this class is abstract. So hence proved, abstract classes cannot be instantiated explicitly. They can only be instantiated by the child classes through the internal mechanisms of Java itself. And let's get started with interfaces in Java. Now, again, let's understand what do we mean by an interface in general, and then we will see how do we apply the concept of interfaces in Java. So imagine, let's take the same example of vehicle industry because that's something which we see every day around ourselves and we can relate to it. So imagine if all the car manufacturers were creating a different way of driving a car. What if in one car you have a steering, but in other car you do not have a steering, but you have something else, which may be called something else. In one car you have the gas pedal to speed up. In other car you have a button to speed up. Similarly, in one car you may have different kind of doors, and in other car you may have different kind of doors, which are completely different looking. It's not even a single simple handle to open it. So you see the problem here. The problem here is that all the car manufacturers are not working on a single contract. They are not respecting a single interface, which will create a poor user experience because whenever the users have to buy a new car or they have to switch from one manufacturer to other manufacturer, they are completely clueless as to how to drive that particular class because the interface they were using in the previous car is completely different from the interface they are being shown in the other car. And that's the basic need for the concept of interface. Think of it as a contract agreement. You see, it is also mentioned here that if you apply the same kind of concept to programming world, imagine if every programmer was writing their own logic in their own way without following a single contract or a single guideline. Soon it is going to create a problem. And that's the kind of problem interfaces try to solve. So interface is again a keyword in Java, and the basic idea or the basic construct is that the interfaces are going to define the specifications of how a class would act. Let me repeat this in a more generic way. Interfaces are going to define the contract or the specification which is going to govern how an application or code or programming logic will behave. That's the basic idea of interfaces. So interfaces are their own type, and the basic property of interface is that it can only contain constants, method declarations similar to abstract classes, and some default methods or static methods or nested types. What is nested type? We will cover that later. Default methods we'll touch upon a bit here, and the static methods as well. But the basic idea is that when you create an interface in Java, you cannot write anything concrete in terms of the behavior of the interface. When I say behavior, always think of that as method. So you cannot define a concrete method in an interface. You can only declare methods. You can also declare constants. You can create a particular type of concrete method by using the default keyword, but use it in very special circumstances. You can also create static methods as well, which are only going to belong to the interface and nobody else. Now let's look at an example. And also before we go to the example, let me also phrase this here that if an interface cannot define a concrete implementation of the methods, then naturally the interface is going to be extended by a child class, a concrete class, which is going to provide the implementation of the methods declared in the interface. It does sound like abstract classes, but there is a difference. Let's understand the difference with the help of an example. This is how an interface will look like. I've used the same construct of bicycle and mountain bike just to maintain some continuity and less context switching. But this is how an interface will look like. You will not use the class keyword, but instead of that, you will use the interface keyword. You can only declare methods. You cannot define methods. Remember when we looked at the abstract classes example, we were able to define concrete methods as well. But in interface, that's a strict no-no. You cannot define concrete methods. Let me show you the abstract class in the case of abstraction which we used. This was the abstract class and it did have a concrete method. right? But bicycle.java here, which is because it's an interface, it is not going to allow you to create a concrete method. Another thing is that if you try to declare a variable inside the class, they will have to be constant. You cannot just declare them without any value. For example, I cannot do this. If I do this, it is going to give an error. You see an error here. And it says initialize field X at declaration, something like this, public static final. So interface is going to force you to declare all the variables as public static final with some value if you try to use them inside interface. So that is also something which interface will mandate. So you see interfaces are more strict. They are more strict in terms of what you can do. You can only declare public static final variables and you can only declare methods. You cannot define methods. So abstract class is less restrictive. Interface is more restrictive. And that is the differentiation which you have to keep in mind, whether to use abstract classes or whether to use interfaces. That is also a very common confusing question in the interviews as well. And remember that interfaces are only for contracts or specifications, where in case of abstract class, you can write a concrete behavior as well in terms of a concrete method in the base class. Interfaces, there's no concrete implementation in the base class. Abstract classes, yes, there can be a concrete implementation in the base class. That's the basic difference. Moving on, I have created a child class here, which is again mountain bike, and it has three properties: seat height, gear, and speed, similar to the previous example. It has a constructor, and remember, again, interfaces cannot be initialized directly, so you do not even need to call a super method here because there is nothing to initialize. You initialize a class to create a state. State is denoted by the properties, but interfaces will force you to write a public static final property and initialize its value automatically. So you do not need a constructor for the interface because there is nothing to initialize. Everything has been initialized in terms of the variables, and the methods are anywhere just declared. That's why you don't need to call super here. After that, the moment you write this particular keyword here, implements, and that is how you will basically extend from the interface. You will use the implements bicycle keyword here. Implements is the keyword and bicycle is the name of the interface. If you write this here, then Java is going to force you to provide the implementation of these two methods. If I do this implements bicycle and if I comment out these two methods, which is coming from the base class, it is going to give an error. And if I read out this error, it says either you add the unimplemented methods or you make the mountain bike class as abstract. There are two ways to fix this particular class. Similar to abstract classes, it will force you to write the implementation of the base class declared methods. Another thing which Java will suggest you and will also force you via some IDEs as well is that you use this particular annotation. We use this particular annotation to tell Java that we are overriding this method from the base class. Since apply break and speed up methods were defined here in the base class, and this child class is supposed to provide the implementation of the methods by overriding them. Overriding is again a concept which we will talk about in detail in the coming sessions. But for now, remember that you need to write this annotation here on the methods which have been taken from the base class to provide an implementation. And the implementation is similar to what we have seen before. So whatever value you supply in the apply break, the speed is going to get decremented by that particular value. And in case of speed up, whatever value you supply in the argument, that value is going to be added to the current speed, and the speed is going to go up. Let's look at the main class here, which is called interface demo. It has a public static void main method. And here I'm again initializing the child class. Nothing strange here. And then I'm using the getter method here because I have made everything as private here. And rest of the things are just here as is. I have the getters and setters here for all the properties, and I'm using those here. So I'm using the getters to just get the value of gear, seat height, and speed. And then I'm applying the brake, and then I'm printing the current speed after applying the brakes. Let me just expand this a bit more. And then I'm using the speed up method, trying to increase the current speed of the bike by 10, and then printing the new speed again. So using the apply brake and speed up methods, which are concretely defined in the child class by using this override annotation. And these were the methods which were declared in the interface, in the base interface. And that's all which is happening in this particular class. Let's run this particular program. And these are the values I get. I get the gear as 1, which is coming from here. I get the seat height as 20, which is coming from here. I get the current bike speed as 10. This was the value which it was initialized with. Then I'm applying the brake. And after applying the brake, the speed of the bike gets reduced and it becomes 10 minus 1, which becomes 9. And that's what gets printed here. And then I'm speeding up the bike by 10. So the current value of the speed of the bike is 9. And if I incremented it by 10, it becomes 19. And that's what gets printed here. And let's get started with multiple inheritance in Java using interfaces. If you remember, I said that multiple inheritance is not possible in Java. And it is not possible because of the diamond problem. Or simply put, a one child cannot have two parent classes. That's what Java says. And let's understand why this is a problem. So I have created a very simplistic diagram to demonstrate the problem of multiple inheritance. And then we will see how we can solve that. So let's say you have a class C, a normal class. Then you created two parents of class C. So basically class C is extending class A, and you also want the class C to extend class B. First of all, it is not possible in Java, and why it is not possible is because of there can be a superclass which is extending class A and class B as well. So you started with class C, you wanted class C to have two parents, which is A and B, but A and B also had a common parent, which is superclass. So now, as you know that the child classes can see the properties of the base classes as well, then if class C wants to access something from superclass, which route should it take? Should it take this route or should it take this route? That is the problem which we called as the diamond problem. And that is the reason why Java prohibits using multiple inheritance using classes. So that's the problem statement, that we don't have a clear route to reach to the superclass from class C, and we try to solve it using interfaces. So let's jump right into the Eclipse IDE to understand how we can solve it. So here I have prepared an example for this particular problem and the solution of it. So again, I'm using the same bicycle and mountain bike example for the sake of continuity. I have created an interface of bicycle which has two declarations, which is for applying brake and speed up. This is my simple interface. And then I have a mountain bike class, which is implementing the bicycle interface and providing the implementation of apply brake and speed up. This is something which you have already seen in the previous example. So nothing new here. And then you have other getters and setters, and you have a main class where you can initialize the mountain bike and get the gear, get the seat height, get the speed. We have covered all of this. There's nothing new here. But now let's say you have a requirement that you have another interface which is called vehicle, and your mountain bike should extend or implement this interface as well. Is that possible? Let's try that. Remember, mountain bike was already implementing bicycle interface. What if you want to have two parents of this mountain bike using interfaces? Like I said previously, that interfaces does solve the problem of multiple inheritance. So let's see if it does solve that problem. So I can just say vehicle here and see if the code compiles. The code doesn't compile here. And the reason is pretty expected. It's because vehicle has a declared method which is called can drive, and mountain bike now needs to provide the implementation of that particular method. So if you click on this balloon and hit on add and unimplemented methods, just double click on that and you will get an empty method definition of that can drive method. And let's put a sys out for simplicity and say mountain bike can be driven. So this is how you can see this code is working fine. And now this particular child class has two parents. It has a bicycle parent and it also has a vehicle parent. So if bicycle and vehicle would have been concrete classes, then this would have caused an error. Let me quickly show you that if I can. So let me go to bicycle and I just change this to class and I put an empty definition for both of the methods. And then let's go to the vehicle class and convert interface and convert that into class as well. And again, provide an empty implementation. So I've just converted the vehicle interface and the bicycle interface into classes. And now if I go back to the mountain bike and if I change this to extends, I get whole lot of errors. If I go here, it says multiple markers and it doesn't give you the right error, but the right error is happening because you cannot extend from two concrete classes. Now, bicycle and vehicle are both classes, and mountain bike cannot do that because Java does not support multiple inheritance from classes. But if you go back to the previous state, if I just quickly do Control Z here and Control Z here in case of vehicle as well, converting both of them back to interfaces and putting the implements back here, everything goes fine. So using interfaces, you can implement multiple inheritance, but using classes, you cannot do that. Let's cover one more interesting scenario. What if you have a need to extend from, let's say, one interface and one more class? Is that possible? Because we saw the combination of two classes that was not possible. We are seeing the combination of two interfaces, which is possible. Now, is it possible to extend from a base class and implement an interface? Let's see what happens if we try to do that. And I have another class. This is not an interface, but this is a class called two-wheeler. So technically speaking, mountain bike is a two-wheeler. And at the same time, mountain bike is also a vehicle and mountain bike is also a bicycle. So what if you have a requirement that your mountain bike should also extend from two-wheeler class? Can you do that? Let's see if I can do that. I will just write extends two-wheeler and let's see if that works. It doesn't work here, but let's put it here. If I put it here, does it work now? Yes, it works. There's no compilation error here, which means Java does accept this particular construct. So what happened here? First thing, when I put this extends two-wheeler after implements, Java did not allow, which means that the extends keyword has to come right after the child class. It cannot come after the implements clause. It has to come right after the child class. That's first thing. Second thing is a normal class, a normal child class can extend from one concrete class and can also implement any number of interfaces. You see, I have two interfaces. So now technically this mountain bike has three parents. It has a concrete class two-wheeler as the parent. It has bicycle interface as the parent. And it also has vehicle interface as the parent. So three parents. So this basically justifies the philosophy or justifies the concept that a class can extend from only and only one base class, but can implement any number of interfaces. You can have more interfaces here, as many as you want. So number of interfaces is not a restriction, but number of concrete classes is a restriction. A child class will have only one concrete base class, but can have any number of interfaces being implemented from this particular class. That's the basic property. And then the main in the main method, you can access any of the vehicle or two-wheeler or bicycle interfaces methods and the classes methods as well if you want to. So for example, if I want to just type this and if I just do dot here, I can access can drive as well. Now can drive was implemented in the vehicle interface or declared in the vehicle interface. Similarly, if I look for the two-wheeler method, can I see the two-wheeler method as well? Let's see if I can. Yes, and this you can see this is the two-wheeler class method which says can rotate two wheels. So I can call this particular method which is coming from the two-wheeler class. I can call the vehicle class declared method which was can drive. So this is also possible, and this is possible because mountain bike is implementing the interface of vehicle. So let's run this particular program and understand the output. So at first I initialize the mountain bike class and I print the gear, the seat height and the bike speed values. You have already seen this. Then I apply the brake and I speed up. So after applying the brake, the speed becomes 10 minus 1, 9. And after speeding up, the new speed becomes 9 plus 10 as 19. Then I call mountain bike dot can rotate two wheels, which is going to invoke the method which is defined in the two-wheeler class, which is printing a simple sysout. So I get the same sysout here. This method is being invoked from the mountain bike object due to the concept of inheritance. Similarly, when I say mountain bike dot can drive, this can drive was declared in the interface vehicle. And then when mountain bike implemented this interface, Java forced it to provide a definition of this particular method. And this is a definition, which is again a sysout. And you can see that sysout being printed here. So this is how you can implement multiple inheritance in Java using the power of interfaces. And you can also combine the classes and the interfaces. The condition is that only one class should be the parent class, and then you can have any number of interfaces as the parent entity if you want to. And let's get started with polymorphism. So polymorphism is a very generic concept, which means that a particular object can take multiple form. Let's not even call it as object. Let's make it more generic. A particular entity can take multiple forms. If any entity in Java exhibits that kind of behavior, then we say that polymorphism is in action. That entity can be a class or an object or even a method. And in today's session, we are going to talk about that type of polymorphism which is exhibited by methods. So we will see how a particular method in Java can take many different forms containing different logics, but still having the same name. And that concept is called method overloading. So whenever you hear the word that you need to overload a particular method, or this is method overloading happening, technically or conceptually, it's basically polymorphism in action, and polymorphism is being applied on a method here. And that phenomena we call as method overloading. So in today's session, we are going to have a look at how we can implement method overloading in Java. So the basic idea of method overloading is that the name of the method should remain the same. So you see in this particular class, which I have created to demonstrate the method overloading. So this is the class name, and the method name, which I am going to overload, is called multiply. And that is probably the first thing which you need to remember to implement method overloading correctly, that the method name is going to remain the same. The type of the return of the method may change. Here you see it's returning int here in the first instance. In the second instance also it is returning int, but in the third instance it is returning double. So the return type of an overloaded method can change. Another thing which can be varied between same method being defined again and again is that the number of arguments and the type of arguments. The first multiply method takes 2 arguments of integer type. The second multiply method takes 3 arguments of integer type, and the third multiply method takes 2 arguments of double type. So by using method overloading, you can vary the number of arguments and also the type of arguments. So the basic idea is that you define the method using the same name, but you do a variation in the arguments or the return types. And that's how you technically implement method overloading. In this particular case, the multiply is the method being overloaded. And in the first case, it is accepting 2 integer arguments and returning the result of multiplication of those arguments. In the second case, the same method name multiply here, the same visibility public, and the same return type, but this time 3 different types of integer values can be accepted, and this method, multiply method, is going to return the multiplication of 3 integer numbers. In the third case, at line 15, I again use the same multiply name, the method name, but this time the return type becomes double, and this method accepts 2 double arguments and returns the result of the multiplication of these double values. So the method name is same, but the arguments vary, and also the return type may also vary. That's the basic premise of how you implement method overloading. So whenever you want to implement it, keep the method name same, vary the arguments and the return types. And after that, I'm just created a public static void main method here. I have initialized the class here, this particular class itself, method overloading demo. And then I am calling the multiply method on the object. And based on the number of arguments I supply, the corresponding method will get invoked. That is something which Java will take care automatically, that whatever type and the number of arguments you supply in the call, in the invocation, based on the number and the type of the arguments, Java will try to find a matching method in the overloaded methods. If it is able to find a method, it's going to get invoked. If it is not able to find the method, you will get an error. In fact, you will get a compile error itself while you invoke a method for which the definition is not available. For example, if I try to just copy this and make an invalid method invocation, Let's provide 4 arguments. And if I do that here itself, I will get the error because Java is not able to find a multiply method in this particular class, which is accepting 4 integer arguments. So you will get the compilation error itself before you can even run the program. But the basic idea is that you use overloading with multiple different types and the number of variables. So I'm calling multiply 3 times. Let's run this particular program and observe the output. So let me just bring this output down. Yep. So first I call demo.multiply and pass two integer values 10 and 20. When this happens, this particular method gets invoked and it returns a result of 10 into 20, which is 200. In the second invocation, I'm calling again the multiply method, but this time with 3 arguments, 3 integer arguments specifically. And this call is going to match this particular method signature, and it is going to execute whatever is written inside this particular method, which is the multiplication of the 3 arguments being supplied. So 10 into 20 into 30, which is 6,000. The third case, let's go back here at line 25. The third case of invocation of the multiply method is accepting 2 decimal based arguments, 10.5 and 20.5. So Java is going to look at the class and trying to find a method which can accept decimal values. And there it is. This is the method signature, which is going to match the invocation. Java is going to do this matching automatically for you. And here, whatever logic you have written inside this particular method will get executed. So 10.5 into 20.5 returns 215.25, and that's the output you get. So this is how you can use method overloading in Java. This is a rather fairly simple example, but you can make it as complex as you want. But a word of caution, do not use it too extensively. In fact, a lot of expert programmers do not recommend using method overloading because it becomes very confusing. Use it only when you do not have any other way out. Use it only where this is the only way to write correct form of methods with the right readability. Otherwise, generally, there would be other ways to avoid method overloading by writing concrete purpose friendly method names themselves. Maybe you don't need to use the multiply name again and again. You can call it as multiply 2 numbers, multiply 3 numbers, multiply doubles, so that the method name itself is more explicit and understandable rather than juggling around different signatures of the same method. Especially it becomes more confusing if you are creating an interface which is to be consumed by a third-party developers or third-party application. So try to use it with caution. That's what I'm trying to stress here. And let's get started with method overriding in Java. We discussed about method overloading concept. Now we'll focus on another interesting concept by which you can have the same signature of the method again and again be used in your code, but in a different way. And this concept is called method overriding. Method overriding basically is used together with the concept of inheritance. You will not be able to use the concept of method overriding without using the concept of inheritance. Remember when we talked about inheritance, I spoke about the subclass and the parent class concept. Sometimes we also call the parent class as superclass. So the basic idea is that if a superclass defines a method, remember I'm using the word define here. If the superclass uses defines a particular method, and then the subclass again tries to define the method with the exact same signature, this phenomena is called method overriding. Now, when you do method overriding, there are some rules to follow. And I'm showing you a tabular structure here, a table basically, which will show you what is possible and what is not possible when it comes to method overriding. So let's try to understand this table. So if you try to define a method with the same signature as a superclass method, the rules follow as per this table. Let's go with the first one. If you have an instance method defined in the superclass, instance method is the normal method which you define in your classes. So if you have defined an instance method in your superclass, and if you define a method in the subclass with the exact same signature, then that concept is called method overriding, and it will be a successful override. Override also, let me also explain what override means here. Override means that once you try to initialize the subclass object, you will be able to invoke its own overridden method definition. if you call that particular method, the subclass's own instance method is going to get invoked rather than the superclass's instance method. We'll look at that when we look at the example as well. But that's the normal scenario where your superclass defines an instance method and subclass also defines an instance method with the exact same method signature. That concept is called method overriding. What if your superclass defines a static method? Static method is basically a method which belongs to the class but not to the object. Instance method is called instance method. A normal method is called instance method because it belongs to the object. You can call the method on the object, but static methods are called by class. So you say class name dot static method name. But when you call instance methods, you just call object name dot instance method name. So that is the basic difference. The static methods belong to the class. Once you have defined a static method, the same static method will be available to all the objects of the class. But instance methods are unique to each object. So that was a short tour of what static methods mean. So if you define a static method in the superclass, and then if you try to define an instance method with the same signature in the subclass, you will get a compilation error. It will not be allowed. It's not allowed in Java to override a static method from superclass. That's what it says. Next one, if your superclass has a normal instance method and then the subclass tries to use the same signature but creates a static method out of it, then again you will get a compilation error. So that the overriding of an instance method to a static method is not allowed. And the last concept is again a very interesting concept and a very popular interview question about method hiding. So if the superclass defines a static method and the subclass also defines the static method with the exact same signature, then the superclass's static method gets hidden. It basically hides the superclass method. So that's the basic idea behind method overriding. So if you see, technically, it's a form of polymorphism because the same method is having multiple definitions. But when we looked at the previous example, the multiple definitions were in the same class. Here, the multiple definitions are in different classes, and those classes are having a parent-child relationship. That was about the theory of it. Let's go to an example of it to understand it better. And I've used again the same construct of bicycle and mountain bike, which we have been using in this series just to maintain continuity. So I have a parent class called bicycle here, which has two properties, gear and speed. It has a constructor, nothing unusual there. And then it has defined three methods: set gear, apply brake, and speed up. Set gear is just setting the new value as the gear value. Apply brake is going to decrement the speed by the value you supply, and speed up is going to increment the speed by the value you supply. Simple. This is exactly what we have seen before. Now mountain bike tries to extend bicycle. So mountain bike becomes a child class. It defines a variable called seat height, defines a constructor called super here, nothing unusual so far. Also defines a setter for height, setter for the seat height, not exactly following the setter construct, but this is just to set the height. But here things get interesting. Let me just bring this down a bit. Yeah. So here it is overriding all the three methods of the base class. And by overriding, it is providing its own implementation of the same methods. Let's compare them. Here, when it overrides the gear and whatever value you supply, it adds 2 to the plus 2 to that value and then sets that value as the gear value. But in case of base class, it was just setting the new value as the gear value. So for instance, if you supplied 1 here, the gear value becomes 1. But here, if you supplied 1, the gear value becomes 3. Similarly, when you apply brake on the mountain bike class, whatever value you supply will be subtracted from the current speed, and 10 would be subtracted even more. So if the speed is, let's say, 50 and you supply the decrement value as 10, so it will be 50 minus 10 equal to 30. But in case of bicycle, if the speed was 50 and you supply 10, then it would be just 50 minus 10, 40. So there is extra 10 being subtracted from the speed when you apply brake in case of a mountain bike. Similarly, for speed up, it's increment of 10 in addition to what value you supply. So again, if the speed was 10 and you supplied 10 here in the argument. So 10 plus 10 plus 10, 30 will become the new speed in case of mountain bike. But in case of bicycle, if you supply 10 and if the current speed was also 10, then it becomes 10 plus 10 only 20. So that's the difference. So the basic idea, I hope you get the basic idea here, is that you override the methods and your own class provides its own implementation of those methods. That's the basic premise of method overriding. All good so far, and you do not have an obligation to override all of the methods, because here we have the concrete implementation of the methods. So here, in case of mountain bike, you can skip overriding one of the methods if you like to. This is also fine. There will be no compilation error because speed up has a concrete implementation in the bicycle class as well. So it's up to you how much you want to override. So let's move to the main class now. So in the main class, we have created the public static void main method here, and let's look at what is happening inside the class. First, we initialize the bicycle class. So bicycle class reference and bicycle class object. Nothing unusual here. We supply the gear value and the speed value. Then we print the gear and the speed value. We apply brake on the bicycle, and then we observe the new speed of the bicycle after applying the brakes. Let me comment out the rest of the code and let's observe the output for only this part of the code, which we just walked through for this section. So if I run this as a Java application, and if I show you what I'm getting here, so bicycle gear is 1, which is what you supplied in the constructor. Bicycle speed is 10, which is again what you supplied in the constructor. Then you applied brake, and when you apply brake, this logic gets executed. And you supplied 1 here, so current speed was 10, so 10 minus 1 becomes 9, and the new speed becomes 9, which is what you are printing here. So far so good. Let's move on to the next section. Let me comment out the previous section now, and let me uncomment this section. So here I have a bicycle reference, but the object is of mountain bike. Remember this concept, this is called dynamic object binding concept or dynamic binding concept. Again, this might be asked in your interviews. So here I'm initializing the mountain bike with a reference of bicycle. Remember, whatever is written on the right hand side will govern the variables and the methods usage. We'll see how that works out, what I just said. So I'm supplying 3 values here, 50, 50, and 3 in the mountain bike. If I go here in the mountain bike constructor, so the start height, start speed, and gear are the 3 values, which is supplied as 50, 50, and 3. Then I'm accessing the gear and the speed. Now remember, gear and speed are declared in the bicycle class, but they are accessible in the child class due to the inheritance phenomena, which we have already covered. So if I print only this part, I should get the expected values. Mountain bike gear is 3, which is what I have supplied here, and mountain bike speed is 50, which is what I have supplied here. Then I apply the brakes. Now let's move on to this section. I apply the brake, supply the value as 1, and then I want to see what would be the new speed after applying the brakes. So let's see what happens when we run this particular code. So if I run this code, after applying the brakes, the speed becomes 39. Before applying the brakes, the speed was 50. So what happened here is 50 minus 1. Basically, this logic is getting executed here. 50 minus 1 minus 10, which becomes 39. That's why you get the value as 39 as the new speed. Similarly, if you want to call another method as speed up method was also defined here, where I'm saying speed plus the argument supplied plus 10. So the current speed is 39 right now. Then I'm speeding it up by 10. So by this logic, 39 plus 10 plus 10, which will become 59. And then I'm printing the new speed after speeding up. So let's see what happens. So if I go to run as Java application, and if I observe all the outputs, the speed was 50 initially. After applying the brakes, the speed became 39. And after speeding up, the speed became 59. So this was a quick demo to show you the power of method overriding and how you can override the behavior which is defined in the base class. And let's get started with the static keyword in Java. Now let's first understand the need of the static keyword, and then we'll talk about how Java implements the static keyword. Imagine a scenario. Let's take the example of a class which we have been using in our different tutorials in this particular series, which is about the student class. So if you are building a college management system, you have a student class there, and if you have an entry, a property in the student class which is storing the name of the college, then the name of the college is going to be the same for all of the students of that particular college. It's not going to change. Another example, let's say you are building a employee management system for an organization, and you want to maintain the employee numbers. For the first object, the employee number should be 1. For the second object, the employee number should be 2. For the third object, the employee number should be 3, so on and so forth. So when you initialize all the employee objects, the last employee object has the final total employee count. And you can also treat this employee count as, let's say, the employee number as the employee ID. So starting from the first employee to the last employee, the employee number is the employee ID, which is a way to uniquely identify an employee. So we talked about two different cases. In the first case, we had a particular value which was same for all of the objects, which was the student and the college relationship. And then in the second example, which I quoted, where all the employees objects have to share a particular property amongst them, because if the second object did not know the previous value of the employee number, it will not be able to get to the new number. It needs to know what was the previous value so that it can do +1. So each of the object needs to know the state of the previous object. Two different cases, two different scenarios, one single solution, which is static keyword. So the static keywords are used for those members which belong to the class. Now apply this definition to the examples which I gave you. If I make a member of the student class, let's say the college is the property of the student class, and if I make that property as static, now that static member becomes the property of the class and not the property of the object. It means it belongs to the class. It also means that all of the objects will get the same copy of this static member variable. And that's one of the first usage. And you can make any property or any member of the class as static by just putting the static keyword in front of it. We also call the static member variables as class variables, like I just described. So use it for the cases where the value across the different objects doesn't change. You can make those class variables and those variables as class variables or static variables. Similarly, also try to identify the cases where a particular value has to be shared in terms of knowing the previous state. In those cases as well, you can use a particular member in that particular class and make that static. For example, in this case, we have a bicycle class and we have a static variable which says number of bicycles. So every time you initialize the bicycle object, this number will be shared. And you can see, this is here, it is incrementing the number of bicycles. So every time you create the object, the ID becomes +1 to the previous count of the number of bicycles. Exactly same example as I gave you for the employee number. So every time you create an object, you do a +1 to the previous value. Next object will take the previous value +1 and so on and so forth. So you can use the static keyword in front of a property of the class and make it a class level variable, which will be tied to the class and not tied to the objects. You can also make the methods as static as well. And the same kind of rule will apply on the methods as well, that the methods will belong to the class instead of belonging to the objects. Let's say you have, again, a common functionality which you want to share amongst objects. Just make that common functionality as a static method, and that would be shared amongst the objects. For example, you want to get the total number of bicycles for the previous example, which I just shared in this particular doc here. So you can just create that method as static, and any object which will call this method will get the latest count of the number of bicycles. You can also make these static variables as constants by putting the final modifier in front of it. So if a variable in a particular class is static and final both, then technically it becomes a constant. So these are some of the interesting use cases and constraints of the static methods and static variables. There's also a thing called static block, which is just a code block which you can write inside your class. And we will have a look at that example as well. So let's shift to the IDE and let's have a look at how we can use this static keyword. So I have used the same class which I have been using in other examples, which is student.java. And you can see I have this same class. You would have seen these properties earlier as well. And the code below is exactly the same, just setters and getters and constructors. and it has an additional property which is college. And the college name XYZ is the same for all the students. So I have just hard coded it. But you see, what is happening here is that every time you create a student object, this variable gets initialized. Even though the variable for all the objects has the same value, still it gets initialized again and again and again. So technically it's a waste of memory. You're just wasting memory of a new allocation every time, even though the value is same. What if we create this object once and this member variable once and just use it across objects? You can do that by just writing static in front of it. If you do that, then you see this becomes sort of italic here, and that's Java's convention to show that this particular variable is a static variable. You can also see the static keyword in front of it. And then whatever value you have specified, this will be initialized only when the class is loaded. Remember, I'm not talking about the object initialization. I'm talking about the loading of the class in the JVM. So the first time the class is loaded, this particular variable will be initialized, and that's it. After that, no matter how many student objects you create, the same college reference will be used again and again, and the college variable will not be initialized again. It will be initialized once, and the same college reference will be used again and again. That's the power of static variables. For example, if I want to access this particular college variable, how do I do that? So let's look at a main class where I have initialized this particular student class with an object named as John, and I've specified the name, the age, and the address, and I'm printing those values. How do I access this static variable? If I say John dot, do I get access to the college variable? Yes, I do have access to it, but does it work? Let's see. You see a yellow line here, and we will come to that yellow line in a while. But let's first see if this works. Yes, it works. I can see that the college name is printed here as XYZ, which I have set. Now let's look at the error or the warning. It says the static field student.college should be accessed in a static way, because the way you are accessing it right now is the instance way of accessing a particular member. This is not a static way of accessing a member. So if you want to access a static member of a class, you should access it with the class name and not the object name. Why? Going back to my original definition that the static variables belong to class. They do not belong to object. And that's why Java will warn you if you are not accessing the static variables via the class, because they are supposed to be accessible via class. It will not give you a compilation error, but if you're working in an enterprise project, this is going to raise a lot of violations and a lot of questions for you as to why you are not accessing it via the class name. So this is the correct way of accessing it, and you will get the same output. Now, no matter how many objects you create of the student class, you can always access the student.college, and you can always get the same value of the college name. That's the first use case. Second thing is about static methods. So you will use the static methods in a case where I described about the counting the employee numbers. And let's say if we have the same kind of scenario where you have to count the number of students, because you can use that particular count as, let's say, the roll number of the student. So if you have that kind of requirement, then you need to create a static method, because you need to share the state of the object across objects. Remember that. So what you can do simply is create a static method. So let's say I create a normal method and then I just put static in front of it, saying static void student count. And now I want to count the student. So let's create a simple count variable and let's start it with 0. And then I can increment the count variable again and again in the static method, right? But you see, I get an error here. The error is if you go to the balloon, it says cannot make a static reference to a non-static field count. This is one of the properties of the static methods. The moment you make a method as static, then that particular method can only access the static member variables of the class. The static methods will not be able to access the non-static variables. Count is a non-static variable. Count is a normal instance variable. So a normal instance variable, for that matter, name or age or address, nothing would be accessible here. If I try to access, let's say I try to access name here. So if I just say sysout and I say name, it will also give me the same kind of error. If I go here, it gives me the exact same error because static method cannot access the non-static member variables of the class. So you have to make this count variable as static as well. And then only this compilation error will be fixed. I can remove this one. And now this method is fine. Now I can increment the count every time that object is created. And that is one of the use case of using the static method, that you can share the state across the different objects. And if you want to fetch this particular variable, then you can simply write a getter for this, saying int count, return count, and then you can return the count. You can see that now an instance method can access the static member. So the reverse is fine. A non-static method can access a static variable, but a static method cannot access a non-static variable. Remember that a static method can not access a non-static variable, but a non-static method can very well access anything, including the static variable. That's second thing. The third concept is of static block. And static block also has a similar usage, that if you have a block of code, it's not just a variable, it's not just a method, but you have a block of logic which you want to execute only once when the class is loaded into the runtime. If that is your requirement, then you can write a static block. And the way you will write it, generally we write it at the beginning of the class. And the way you will write it is as you write static and you put curly braces and you start writing code here as to whatever. You can say initializer, and you can write whatever code you want to write. The only caveat is that in the static block, you will only be able to access only the static member variables of the class. So you will not be able to access these variables. You can only access these two variables. You can very well move these two variables here if you want to. So if I go here, I can paste this and I can drop the static keyword, because everything in the static block is automatically static. So I don't need to explicitly call out static variable. And now this code is fine. You get some warning because it's not used anywhere in the class, but that's fine because this is just a simple demo. But the whole point is that you can write the static block and you can write all the initializer code which you want to write here, which you only want to execute once during the whole execution of your program. Just to show you the reason and the way it works, let's try to see if the static block works. And let me comment all the static code which I wrote here. And let's go back to the static demo and let me remove this one as well. So now I just will run this student.java. I will create an object of student.java and I will see if the static block gets executed or not. So let's run this particular class, which is the main class, and I have a main method. I have a student object initialized and I'm printing the name, age, and address. If I run this, you see the first line of code which gets printed in the output console is the static block code, which is what I wrote here. And let me do one more thing just for fun's sake. Let me create more objects of it. Let me just call them 1, 2, 3, and 4. And let's see how many times the initializer code gets printed. You see that the code still gets printed only once, even when I created 5 different objects of the student class. And that's the property of the static block, that it will be executed only once when the program is loaded into the runtime. And that's all. And let's get started with nested classes in Java. So far we have seen that we can create classes in Java and we can create objects of those classes to interact between those classes and objects and other properties as well. But what if you have a use case, or what if there is a need that you need to define a class within a class? So that's the concept of nested classes, that Java does allow you to create classes within the classes. Now, you might be wondering as to why do you want to do that? And the simple answer is encapsulation. You would be facing some scenarios while writing enterprise grade applications where you have a class which has its own scope, but that whole scope or the existence of that class is justified by another class. For example, if you try to design an object-oriented design for a house, then a kitchen cannot exist without a house because the kitchen exists inside the house, right? So if you have that kind of relationship, then probably kitchen class has to be inside the house class somehow. And that's where this nested class concept will come into picture. And that's why we have this nested class concept here. As you can see, what I'm showing on the diagram, that Java programming language allows you to define a class within a class, and that is called nested class. Now, when we talk about nested classes, you will hear two different terms. Basically, nested classes are divided into two categories, which are static classes or static nested classes and non-static nested classes. Now, static nested classes are called simply static nested classes, and the non-static nested classes are called inner classes because they are non-static, they are just normal inner class. Exactly similar to the way we say a normal method and a static method. Similarly, if you put a static keyword in front of a nested class, that becomes a static nested class. And if you do not put static keyword in front of a nested class, then it is simply treated as a general inner class. That's the overall concept. Now there are some more drivers of why you would like to use it. One example is I gave you about the existence of an object within an object, or technically speaking, the existence of a class within a class, the whole house and kitchen analogy, which I just shared with you. But broadly, you will see these different reasons due to which you will be using nested classes. First of all, it's a way to logically group all the related classes that are only used in one place. What it means is that if you have a class which is only serving the purpose for a larger class, then it's better to group those two classes together inside a single class, or simply nest the smaller class inside the bigger class. I might be using the term inner class and outer class to point out the static nested inner class and the outer class. That's the first reason. The second reason is, like I said, it increases encapsulation because now you have full control over what you can expose and what you cannot expose, or what you should expose and what you should not expose. Because inner classes will also come with its own set of visibility constructs like private, protected, etc. So you get more fine-grained control in terms of what you want to expose to the outside world collectively from the outer and the inner class. And it can lead to more readable and maintainable code, though I would honestly say that this is debatable because in a lot of programming languages, static nested classes are not promoted because they drop readability. Imagine if you have 10 classes, if you have a single class and if you have a nested hierarchy of 10 classes, it becomes super confusing and super complex to track the visibility of the variables and also to understand the code better. So this is debatable whether it improves to readability and maintainability or not. Maintainability, yes, to a sense, because you have a single class which is containing the logic of a inner helper class and the outer class. Readability, yes or no, it depends. If the classes are small size, then yes, it does improve readability. If they grow larger, then it's better to move the class outside and just make that class maybe a package private or something. So this is the basic premise of why we use nested classes. Now let's talk about an example by which we can demonstrate how to work with the static nested classes. So here I have created a class. It's a simple class, but I've just named it as outer class so that we understand that this is the outer class. So I have a class here which is named as outer class, and at line 5 I am defining a static variable inside the class. You can see the static keyword here, and I've just called it as outer static member. Then I have a simple instance variable. This is something which you have seen normally in all the different examples I have given you. And then I have another static variable, but this is private. So this one is a normal static variable. This one is a normal instance variable. And this one is a private static outer variable. All these three variables are sitting in the outer class, but this is private, this is static, this is private static, and this is a normal instance method. And we will see how we can access these variables inside the static nested class. To define the static nested class, the way you will write it as you will be inside the class opening and closing braces, and you will start writing like this: static class and the name of your class. That is how you're going to define a static nested class. And then you put the curly braces, and whatever goes inside it is just like any other normal class you would write. So let's say inside this static nested class, I have defined a method called display. And now I am trying to access this particular variable, which was a static variable defined in the outside class or the outer class. We will see if we can access these static variables from the outside class or not. So that is what this system.out.println is doing. I'm just accessing this directly. You can see you can directly access the outer class static member variable inside the static nested inner class. Then in the next statement, I am accessing the outer private member, this one. So the outer private member, which is also static. So these two static variables are being accessed here in these two lines basically. And then I have commented out one more thing to try out if I can access the normal instance member. Also remember the concept which I taught you in the previous session, that a static method or a static block can only access static variables. A static block will not be able to access non-static variables. So these two are static variables and this is a non-static variable. So we will see if the same construct still applies on this particular class or not. So inside the display method, I have these two sysouts and this one is commented out. I will come back to that later. So you have your outer class and your static nested class ready with a sample method. Now let's see how we can invoke these outer and inner classes. How do we create the objects of an inner class? So for that, I have this static nested demo class. It's basically containing a public static void main method, as you can see here. And let's try accessing a static nested class. So if you want to initialize or access the inner static nested class, then you have to follow this kind of construct where you say outer class dot inner class name, then you give a reference to it. And again, you follow the same construct. You say new outer class dot static nested class name and a simple parenthesis. And this is how you are going to create an object of the static nested class, which you had defined inside your outer class. Remember the syntax. This is how you're going to do this, that you type outer class dot static nested class. Once you have done that, it will call the default constructor of static nested class and you will get an object. Now you will also see the dependency which I talked about. There is no way that you can initialize this static nested class without referring it from the outer class. You always have to write this outer class dot to access the static nested class. You will not be able to access or use this static nested class directly anywhere in your program. So the whole concept of the inner class only existing with the outer class holds true here, because the inner class only can exist if you refer it from the outer class. Once you have the object, you call the dot display method and let's see what happens. So if I run this particular program and let's see what kind of output do I get. I get 2 lines of output when I call the display method. So let's go to the display method where I am doing a sysout for the static member of the outer class, which was this variable. So that value gets printed as 10. And then I'm printing the private static member of the outer class, and that also is accessible. So it means that you can access the normal static variable of the outer class and also the private static variable of the outer class inside a static nested class. That's one part of it. Now let's uncomment this and see if this works. You see that you directly get a compilation error and you don't even have to wait for the program to be run. You see that this particular variable instance member variable is not accessible. So this also verifies our understanding which was built previously in the previous session, that static blocks can only access static members and those static blocks will not be able to access any non-static variable or member. And this was a non-static member. And let's get started with inner classes in Java. We talked about the static nested classes and we are going to focus on the non-static nested classes. We also call them simply as inner classes. So whenever you hear the word inner classes, always clarify whether they mean the static nested inner classes or the non-static nested inner classes, because people may use different terminologies. But the official or the standard terminology is whenever somebody says inner classes, it means the normal nested class. And when somebody wants to convey static nested classes, they will use explicitly the word as static nested classes. So when we talk about inner classes, they look a bit similar to the static nested classes, with the difference that you will not see a static keyword while you define the inner class. That's the one type of the simplest inner class you can create. It follows pretty much the same kind of construct where you define the outer class and you define the inner class and you write the logic inside the inner class. So let's understand this with the help of an example, and we will also talk about the other type of inner classes which we have. So with that, I want to switch back to the Eclipse IDE, and let me comment this one out because I will cover this in a while. And let me fix an error here as well. So I will comment this as well. Okay, so let's talk about the demo which I have prepared. It's a very simplistic demo just to understand the concept. And please do practice all of these concepts in detail to get more confident about these. So I start defining a normal class, just naming it as outer class. And then you can create a class within a class. I'm calling it as inner class. You can obviously name it as anything you want. And you can write any logic which you want to write inside your inner class. Here I just have a display method where I have a simple sysout, which is verifying if I can invoke this particular method or not. So if you have this simple kind of construct of outer class or inner class, how do you initialize the inner class? Remember when we talked about the static nested classes, and if you wanted to initialize the static nested class, I had to follow this particular syntax where I said outer class dot inner class on both sides when I try to initialize the object. But if I want to initialize a normal inner class or a non-static nested class, the way to do that is like this. So on the left hand side, you again follow the same kind of construct where you say outer class dot inner class. You write a reference for it, and then you say new outer class. Here you are creating an object of it dot new inner class. So you basically first initialize the outer class, create an object of the outer class, and then that object of the outer class can be used to create an object of the inner class. So this is the difference. If I take you back to the static nested classes initialization, here on the right hand side, it was simply outer class dot inner class and then the parenthesis, because this was a static member. So you access the static members by the class name. That's why class name dot static member. But you access the normal instance members via the instance and not the class name. So you need to create the instance first. And then once you have created that instance, then you can access any member variable of this class. And inner class technically is just a member variable, which has been initialized here. So this is how you're going to initialize an inner class. Then you get an object of it. And once you have got the object of the inner class, then you can call the display method. And whatever is written in the display method shall be executed. Let's run this program. Yes, I can see that the display method is getting called and it is printing whatever was written inside the display method. In the display method, I just simply had a sysout which said this is an inner class method, and that's what is getting printed here. That's one type of the inner class, which is looking very simple. Another a bit more complex and special type of inner class is called method local inner class. When I say method local inner class, the name itself explains what it means, that you are trying to create a class inside a method of the outer class. So let me just uncomment this part. So this is a normal method, normal instance method of the outer class. And inside the method, I create a class. You see, inside the method also you can create an inner class. That is also something which is supported by Java. And that's what I'm trying to showcase here. That when I define the outer class method, I write my whatever logic I want to write in my method, and then I can create an inner class, a method local class basically. I've just named it as method local class to just look it more readable. And then you can define anything you want to write inside your method local class. Here I have just defined a simple method called local inner method, and I have just printed a statement inside the local inner method which says in the method local class method. Once I've defined the class, then within the method, I can also initialize the class if I want. You can see I'm creating an object of the method local class within the enclosing method. That is also possible. So I create an object called MLC, and then once I have the object, I can invoke this method by the object, and that is what I'm doing here. So this whole logic can be just embedded inside a particular method, and we call this type of class as method local inner classes. This is also a type of inner class, but this is just to show you that you can also create method local inner classes. So this is what I've done here, and if I invoke this outer class method, what happens? Let's see that. So here I have written the code to simply initialize the outer class. Nothing new here. This is a normal initialization. And once I've done that, once I've got an instance, then I say outer class dot outer class method. I simply call the instance method. And once I call the instance method, everything is written inside the instance method gets executed. So first I should get this statement, then the class will get loaded and compiled, then an instance of the class will be created, and then whatever is written inside the local inner method will be executed. So technically I should see this sysout and ultimately this sysout if I run those two lines. Let me comment the first part so that we can observe the output correctly. And I run this as a Java application and I get these two lines. So I get the in the outer class method statement, which is coming from here. And then this whole code gets executed, and eventually when this method gets called, I get this statement as well, which is in the method local class method. So this is to show you how you can invoke the method local classes. Basically, there's nothing new here. It's just a normal class. You instantiate the normal class and then you call the object. You get an object and you call the method on the object of the method local class. Now there is another type of inner class which is called anonymous inner class, which we haven't covered so far. Anonymous inner classes are not very common, but sometimes you might need to do that. You might need to create anonymous inner classes, but always first understand and discuss with your teammates as to if there is a way to avoid anonymous inner classes, because they are not very readable. But let me cover that as well as part of this curriculum. So if you have to implement anonymous inner classes, let's first understand why do we need to implement anonymous inner classes. And I would like to do that with the help of a demonstration. So I have again created a simple interface of bicycle, and I will create an implementation class called mountain bike. So you see a bicycle interface, and I have two methods which says can speed up and can apply brake. Just simple two interface methods being declared here. Then I create an implementation class called mountain bike, which implements bicycle. And if it implements bicycle, it has to provide the implementation of those two declared methods in the interface. And that's what it does here. And for the sake of simplicity, I'm just printing a sysout here. All good so far. And then if you have to access or create an object of this mountain bike class, the way you do that is simply by just saying bicycle mountain equal to new mountain bike. Remember, I'm using the bicycle reference here, but the object is of mountain bike. So when I call anything on the mountain bike, then that implementation of the mountain bike will be invoked. So I'm just invoking the can apply brake method and can speed up methods. Nothing new here. You have already seen this when we were talking about interfaces session. But what if you want to create an object of the bicycle class itself? You don't want to create a mountain bike class at all. Is there a way to avoid creating mountain bike class and still being able to write this logic? Yes, there is a way, and that is the anonymous inner way. So I can just say bicycle equal to new bicycle. If I say new bicycle, remember I'm not saying new mountain bike because mountain bike does not exist, or I don't want to create mountain bike class. Then you can write this instantiation right for the interface class. But the moment you hit control space, and you will get this option where it will say, okay, I will get you an object of bicycle interface, but it has to be of anonymous inner type, which is lying in this particular package. So if you just click on this, this whole code will be generated for you. So you see, the moment you double click on this whole code was generated automatically for you, which is providing everything, technically everything which you wrote in the mountain bike class. So the whole logic which you could write in a child class gets embedded right into the instantiation code itself. And this is your anonymous inner class. You see, it automatically looks a bit ugly. And imagine if you're writing this for a real production code where each of the methods may have a lot of logic and you may have a lot of methods, then it can grow very long and it can look very ugly. That's why I was saying always try to create a child class instead. It can be a simple use case, but try to create a child class or try to avoid writing anonymous inner classes if you can. If there is no way out, then this is the way you do it. There's also a bit nicer way to do this using Lambda function for functional interfaces, but that is also something which will not improve the readability a lot, though it will make the code look smaller. So here you can write the exact logic which you want to write in can speed up and can apply break. Basically, whatever you wrote in those two methods in the mountain bike class can very well be written here, and the code will still be executed. So let's just do that quickly. So I will just go here and copy the sysout from speed up method. I'll just put it here, and I will copy the can apply break method, and I will put it here, and I will comment the mountain bike code. So I've created the object of bicycle class here, and now if I say bicycle dot can apply brake, and I can say bicycle dot can speed up. So now I can access these two methods, and the implementation will be invoked from this anonymous inner class implementation. So if I run this, I will get pretty much the same output. Yes, you can see I get exactly the same output. It's currently printing both of these sysouts as the same because I did not change the sysout here. And yeah, I have written the exactly same text in both of the cases. So if I just change this text to say can apply break, and I do the same thing here, I say can apply break, and if I run this, so you get the same output. And if you comment this back, and if you use the above code, you also get the same output. Yep. So that's the basic construct of anonymous inner classes, that you can use the interface instantiation. If you do not want to create a child class of it, just instantiate the interface, and Java will automatically generate the concrete override implementation for all the methods which are declared in your interface. And then you can provide the implementation of those methods inline. And let's get started with packages in Java. Now, I have been using the concept of packages all the while in all the sessions, but we never focused particularly on packages and why we need them, how do we create them, what are the thumb rules. So we will focus on all of those questions in this particular session. So first of all, just to get the definition out, a package is basically a grouping of related types. Now, these types can be classes, they can be interfaces, they can be abstract classes, they can be nested classes or whatnot. But the basic idea is that you try to keep everything which is related to each other at one place. It's quite similar to how you arrange your house, or how you arrange your office, or how you arrange your work desk. You try to keep the similar kind of stuff together. For example, you might have a particular rack in your almirah where you keep all the books. You might have a different rack where you keep clothes. Generally, you won't mix books and clothes together in a single rack, right? Because they don't belong together. And that's the concept basically which Java packages try to put you or give you to implement in your programming language and your project as well. So it's a logical way of grouping related classes and types together. That's what packages do. And if I take you back to the Eclipse IDE before I go any further, you will see all these square looking objects, right? These all are packages. You see the square icons, these boxes, these are packages. And the way you create packages is basically, if you just go to the SRC, let me go back to the SRC, and you right click on this, you go to new, you will get an option of package. So you can go click here and write any name of your package. Let's say test.package. Couple of things to note is that packages follow this convention of dot, and that is how you nest a package into other, or that is how you create a hierarchy of packages and sub packages. So you can create this as a package, which is fine. And you can also create dot something else, dot something else, dot something else, and you can go further as well. Other thing to notice is that this will not accept keywords. You can see it says else is not a valid Java identifier because else is a keyword, a reserved keyword in Java. So make sure that you are not using those reserved keyword names in this particular package name. So it can be test dot, test1 dot, test2 dot, test3, whatever. So just make sure that you're not using keywords here, and you can create the hierarchy. Now, how do you name them? Different organizations and different project teams follow different naming conventions. This is your area. This is fully customizable, so you can write it the way you want it. Generally, what companies do is they put their domain name from the backwards. So for example, google.com might have a package called com.google. Similarly, amazon.com might have a package called com.amazon internally. this is something which might have been there, but they might have chosen something else. But this is sort of the standard convention that you just reverse the domain name of your application and you write the package name backwards. That is the general convention. And after that, once you have written that, let's say if you have written com.google, this is the top domain name. Now after that, you specify what you want to do. Let's say you are implementing a web package. Then you can be even more specific. Okay, web package is a huge package. What is specifically this package will be doing inside the web package? So let's say HTML might not be a right example, but let's say some front end auth logic, let's say. So now this can be a valid package, because if somebody reads the package, they can understand what would be lying inside the package. This hugely improves readability, and please do spend good amount of time in naming your packages right, because once you write the code is going to be living for many years to come, and many other developers, once you leave the organization, many other developers will be looking at that code, and you would like to make their lives easy by understanding the code by just looking at the package name. So please name the package names correctly. And once you have written this package name as, for example, in this case, front-end auth logic, or let me say front-end dot auth logic. Once you have written this package name as auth logic, then make sure that only the classes which belong to this particular business requirement are present inside this package. No other unrelated class should go inside the package. That is something also which developer have to take care of. So this is again the responsibilities of the developers, that they make sure that whatever goes inside this particular package is only relevant to the package. There's no irrelevant stuff which should go inside the package. Again, this is to improve readability, searchability, maintainability, and tons of other out of the box benefits you get. So that is how you create the packages. Now let me go back to the documentation and talk about why would you use that. Let's look at some of the more benefits of it. So if you scroll down in this official documentation, you will find bunch of reasons and benefits of it. First of all, you and other programmers can easily determine that these types are related, because if some classes and some types are sitting inside a package, then there is an expectation that those classes and types serve the purpose of that package only. It also provides a benefit that you and other programmers can easily find the types that can provide a particular type of functionality. Again, the same concept of aggregating single functional classes into these packages. That if you are writing, let's say, a banking application, and if you have a package called interest rates, then everything inside the calculation of the interest rate and the specification of the interest rates should sit inside that particular package only. Similarly, the names of your type would not conflict with the type names in the other packages. That is also a huge benefit of packages, that once you start writing a particular class inside a package, and if you make that particular class as private package, then that particular class will be visible only within the package. And you can again recreate the exact same class with the exact same name in another package. Let me give you an example. So if I go to, let's say, the inheritance example, here I have a class called bicycle. This is a bicycle class. And if you see, strategically, I have not put public here. I have removed the public identifier here. So this class is only visible within this package called .inheritance. This particular class will only be visible in this package to these other classes. Now, if I go, let's say, if I go to method overriding, I have another bicycle.java here. If I open this, this is also a class. These two classes are exactly the same, but they don't conflict with each other because both of them are package private and they live in different packages, and only those packages can see them. This particular class is present in this particular package, which ends with .method overriding, and this particular class ends in a package which ends with .inheritance. So if I go here, let's see, if I go to the main class, and if I try to type bicycle and I put control space, you see I only get the suggestion of this package private bicycle class, which is sitting inside the method overriding package itself. What if I change the visibility of this inheritance package bicycle class to public? Let's make it public. And now if I go back to the method overriding demo, which is sitting in the method overriding package, where I already have a bicycle class. And now if I type bicycle and I do control space, I get two options. One is from the local package, And because I have made the other bicycle class as public, I get that as well as a suggestion. And if I import this one, you see now the inheritance package bicycle class has been imported in the method overriding package. It can create a lot of confusion. That's why it is always a good practice to work with the access modifiers really well and try to restrict the visibility of the classes to what they should be accessible at. And that's why it's a good practice to keep the classes within the package private visibility so that they're only visible within the package. This will help you in a lot of ways, providing any kind of problems around ambiguity. So ambiguity is a big problem when you have huge projects with a lot of similar class names. And let's get started with recursion in Java. So let's first understand what do we mean by recursion, and then we will look at the details of the class which you are seeing on your screen. So recursion is the phenomena of a method calling itself. So we have the scenarios where we call a particular method on an object, right? But what if you have a scenario where a method wants to call itself? Now you might be wondering why a method would call itself, because this will go into an infinite loop, right? If you write a method called sum and then the sum inside the sum method, you again invoke the sum method, then this will keep running into loops till your program goes out of memory. I will show you the example of that as well. But the basic idea is the use case where if you have a need where the method wants to call itself, that is where you will use the recursion concept. Another thing, whatever you can achieve with recursion, generally you can achieve the same output using for loops as well. But when you use it for loops, it will require you to write a lot of code. Recursion will reduce the number of lines you need to write and manage in your code. But on the other side, recursion can get a bit complex because it requires an advanced understanding of how methods actually work in Java. So before I go any further, understand that methods, whatever you define inside the method, that goes onto a stack. Remember, I covered about stacks and it's a LIFO arrangement. So whatever you define inside your method, all those variables and all those statements, they go onto a stack. And then the stack gets emptied one by one, executing the statement which is sitting on the top of the stack. That is the concept of the method execution, that under the hood it is using a stack. Now, when we talk about the recursion, it also follows the same stack insertion and stack item removal concept, that how do you insert elements into the stack and how do you remove them. So we are going to walk through an example of recursion with the help of a use case called factorial. Now, if you have studied about factorial in your school classes, you might remember that factorial is a way where, let's say, if I have to calculate the factorial of 10, then it would be 10 into the factorial of 9, into the factorial of 8, into the factorial of 7. So you see, I'm repeating the concept of calculating the factorial again and again. First, I'm calculating the factorial of 10 into factorial of 9. Then I say 9 into factorial of 8. Then I say 8 into factorial of 7. Then I say 7 into factorial of 6, and so on and so forth. So this is the concept of how do you calculate factorials. Another example where you can use recursion is a Fibonacci series. So when we talk about the Fibonacci series, the basic idea is that you sum the previous two elements, and that's how you create the next element. Then you sum the immediate previous two, and you create the next element. So again, you perform the operation of summing the past two elements again and again to calculate the next element. So you see, again, you're repeating the same operation again and again. So try to identify that particular thing where you have to repeat the particular operation again and again on the whole sequence. That would be the use case where you might be needing to use a recursion concept. So here I have prepared an example for calculating the factorial of a number. So what you see on your screen is a class called complex function, and then it has a method called calculate factorial. And inside the method, you supply an argument, which is basically a number for which you want to calculate the factorial. So if you supply 5, a factorial of 5 will be calculated. If you supply 10, a factorial of 10 will be calculated. Now, the first thing which you need to do when you write a recursion function is to know the exit condition. That is probably the most important concept when you write recursion. You should know when to end the program. If you get it wrong, then your program will be stuck into an infinite loop, and it will only exit when there would be a stack overflow. Basically, there will not be enough memory inside the JVM to run your program. It will crash technically. So remember always to define a exit condition. Some people also call it as a base condition, but remember the base case or base condition or the exit condition. Either of the terms can be used interchangeably, but always remember to first define the base condition. So here, when do you end calculating the factorial? You know the factorial of 1 is 1 and it cannot go any further. So that would be your base condition, that once if you encounter a scenario where somebody inputs 1 as an argument, then you simply return 1 because the factorial of 1 will be 1. So this is your base case. This is what is going to make sure that your program exits smoothly. If you get it wrong, your program will never end. It will go into an endless mode. Then in the else condition, you write the factorial logic based on the recursion. So like I said, what does a factorial function does is if you calculate the factorial of 5, then it would be 5 into factorial of 4, 4 into factorial of 3, 3 into factorial of 2, 2 into factorial of 1, and that's when it will end. So here I'm saying, let's say if n was 5, so you say 5 into, you again call back the same function, 5 into calculate factorial of 5 minus 1. So now again the function will be invoked with an n equal to 4. It will go here, this condition will not be met because n is 4. It will go to the else block. Again the same thing will happen, 4 into calculate factorial of 3. So you are again invoking the same function, but this time supplying n as 3. So it will go here, n will be supplied as 3. It will again check the base condition, n is still not 3, n is still not 1. So it will go to the else block. So 3 into calculate factorial of 2. It will again go up, and again it will invoke the calculate factorial method, but this time with n equal to 2. This condition is still false because n is still 2. It will go to the else block and it will say 2 into calculate factorial of 1. It will again go up. This time it will invoke with n equal to 1, and it will go here and it will satisfy the condition. And that's where your program will have its first output. You remember previous execution of 5 into factorial 4 into factorial 3 into factorial 2 did not result into an output. These were the executions of the method call which were just going on the stack. So you were just, at first you had the calculate factorial of 5 on the stack. On top of it, you had the calculate factorial 4 on the stack. Then you had calculate factorial 3 on the stack. Then you had 2, and then you had 1. But when you had 1, your program did received or reached a particular end. So that was your first output. Once you have your first output ready, then you go back to the previous one. So the first statement has been popped now. You go back to the calculate factorial of 2 and you calculate that. Once you have the output of that, then you go back to calculate factorial of 3. And so you basically unpack the stack now. You basically try to remove the elements from the stack. To visualize this, this is how it will look like. That you first call the factorial 5. Let me just change the name of it just to make it look exactly how it will go on the stack. So this is how it is going to go on the stack. So you call the calculate factorial of 5, which in turn called the calculate factorial 4, which in turn called calculate factorial 3, calculate factorial 2, calculate factorial 1. And once you had the calculate factorial 1, you got the first output. And once you had the first output, then you start unpacking it because you had the value of the calculate factorial 1. So you can say 2 into calculate factorial 1's output. Calculate factorial 1's output was 1. So 2 into 1 becomes 2. And this is the output of calculate factorial 2, right? Then it goes to the next step, basically this one. And calculate factorial 3 was demonstrated as 3 into calculate factorial of 2. So 3 into calculate factorial of 2, which is this one, 2. So this gets replaced here 2, and you get the output as 6. Now you have this one also resolved. The next one on the stack was calculate factorial of 4, which was written as 4 into calculate factorial of 3. So 4 into calculate factorial of 3's output. So this function calls output. This function's call output was 6. It goes back and it says 4 into 6, 24. And you have this one also calculated. Now you go to the last statement, which was calculate factorial of 5, which was written as 5 into calculate factorial of 4. And calculate factorial of 4 has been already computed as 24. So now you can simply say 5 into 24. which is the output of calculate factorial 4, and you get the output as 120. And this is the final return statement which will be returned to you. So if you try to understand this, till this particular point, you were just calling function after function after function with a different value of n. And everything started getting into a result due to the base condition. This was the base condition. And that's why the base condition is very important. Now imagine there was no base condition. Then this would never return, and it will keep calling calculate factorial, and it will keep going down the stairs. It will never be able to come up because there is no base condition. And that's why base condition is very important. At the same time, also understanding how recursion works is also very important. Always remember that the output of the first execution gets supplied in the second execution. The output of the second execution gets supplied in the third execution, and that's how the stack unpacks or empties itself. So here I'm just doing the normal drill here where I'm saying complex function equal to new complex function, and then calling the calculate factorial method, passing 5 to it, and then printing the eventual result. And if I run this, I get the output as 120, which I just walked you through. So remember how to use the recursion, why to use the recursion, how to define the base condition. All of these things will be of very much importance when you try to implement recursions. Practice this a lot. Recursion is a concept which takes time to get used to. So practice many different examples and many questions of recursion, and you will be more confident about it. Read more about this concept in the Java docs. Look at different examples on the internet. That will help you build more knowledge around this. And let's get started with method calling in Java. Now, when it comes to defining the methods, I have been talking about methods throughout this particular series. And the syntax is pretty familiar, where you first specify the access modifier, then you specify the return type, then you specify the actual name of the method, and after that, you specify all the arguments which this method is going to accept. And inside the curly braces, you do your calculation, and based on the return type, you return an appropriate value. We have seen many examples of it, and let me show you a quick example to just understand the method anatomy better, and then we will talk about how do we pass arguments to methods. So in this simple class student, I have some properties, I have constructor, and then I have methods. These all are also simply methods. You can see we have an access modifier, which will decide whether this particular method should be visible to the outside world or not. You can also either remove this particular access modifier or make the method private if you want, or you can also make the method protected if you want. So all of the possibilities are there, and what kind of access modifier will you keep depends upon your use case. So that is the access modifier. And then if your method is not supposed to return anything, then you would just say void. Void is the default keyword in Java, which is used for use cases when you do not want to return something. Void just means empty or nothing. So when you have nothing to return, you are going to put void. You cannot skip this. If you remove this, the method signature is not complete. So you have to provide this. There is no way around it. So you need to provide the method return type. After that, you provide the name of the method. This is a free text string, and you can name it whatever you want. Just follow the camel casing convention, where you start with a small alphabet, and for every new word in the method name, you start with the first letter as capital. After that, you put normal braces and you supply the arguments which this particular method is going to accept. For example, if this method was about calculating interest, then probably you might supply the interest rate as the argument and the principal as the argument. If this method was about calculating the price of the car, then you might supply all the different mileage details and the manufacturing details, which would decide the price of the car. So it depends upon what you are doing, and that's how you will understand what kind of arguments your method is going to need. When you define the arguments, you need to define the data type of the argument, and again a name which you can give it as anything. This is again a free text string. And after that, it depends upon you what kind of logic you want to write inside the method. The basic need for writing a method is to not do the same thing again and again at every place. If you have a functionality, let's say if I take the same example, if you have to calculate interest and the interest calculation logic is required at, let's say, 15 different places in your application, then just create a single method for calculating the interest rate or the interest, and then just reuse that method again and again at different points in your application. Just call that method. That's how we use it. So that is the basic idea of creating a method to keep reusing the functionality over and over again across all the different methods in your application. Let's take another example of this particular method because it has a return statement. Again, I specify a public access modifier. I specify the return type, which is string in this case. Then I specify a name of the method, and I can also choose not to supply any argument if the method does not need any argument to do its computation or to run its logic. If you put a return type, any other return type, then void here, then you have to provide a return statement. The return statement will be the last execution step of your method. Remember that. The return statement will be the last execution step of your method execution. This has to be provided if you provide a return type other than void inside your method. In this particular case, this method expects a string return type, which means when I call getName, I should get a result back, which should be of type string. Then I need to write a return statement and return a variable which should be of string type. For example, if I just change this method to say, let's say if I say int I equal to 1, and if I say return I, this is going to give you an error. You see there's a compilation error, and if you hover over the balloon icon, it says cannot convert from int to string. It is trying to convert this particular return type and trying to match this into this particular return type, and it's not able to match int to string, so you get an error. So it has to exactly match the return type, the data type of the return value which you have put here. It has to match exactly with the return statement variable type. If it doesn't match, you're going to get a compilation error. That's the first thing. Now, there might be scenarios where you have multiple branches of execution in your method. For example, let's say, if I just use this condition of I equal to 1 and I write if I equal to 1, then return, let's say, a test string, else return the name. I'll just cut this and put it here, and we'll change this to name. This is also possible. And this is possible because of the same statement which I told you earlier, that return statement has to be the last execution step of your method execution. In this particular method, there are two branches of execution. This is one branch and this is the other branch. At a particular time, either the if block or the else block is going to get executed. There would never be a case that both of the blocks get executed in the same execution cycle. It will always be either this block or this block. And that's why if you use these kind of statements, then you have to provide return type in each of the branches. You can also do something like this. Let's say if I say string return var equal to null, and then I say control C, control V, I assign test string to the return var, and then here also I assign name string to the return var, and at the end I say a single return, and I say return var. This is also fine because here I am just assigning different values in the if block and the else block, and then just returning the placeholder variable, which is also absolutely fine. So you can use either of the way. The better way is to return from within the branch itself. So this was a quick tour for you to see how methods work and what kind of anatomy method represent. Now let me just quickly revert everything which I did here and bring it back to return name. That's good. And now let's talk about the method calling patterns and how do we call the methods. So for that, I have prepared a class called method calling demo. It has a public static void main method. And here I have just declared a simple variable I and initialized the value of I as 1. Then I'm calling a method which is named as change value. And if you go to this particular method, it has a very simple implementation. It is accepting the argument which I created here. I'm passing this particular variable as an argument to this method, and then whatever argument I supply, I'm incrementing that argument by 1 and just return and not returning anything from here, just incrementing the value of I, and that's it. And after that, I'm printing I. So what would be your guess here? What would be the value here? I'm going to pause here for a moment and to let you think about what is going to happen. Okay, I hope you would have done some calculations in your head to see what is going to happen and what is the value of I eventually at line 8. Let's run this program to understand that. Okay, so I had initialized I as 1, then I passed the value of I in this particular argument, and I said I equal to I plus 1. So it should be 1 plus 1 equal to 2, and the new value of I should be 2. But at line 8, I still get I as 1. Why is that happening? It's happening because of the concept of pass by value. Remember that concept that in Java, every argument which you pass to a method is passed by value and not by reference. In simple language, what does it mean is that when you pass this particular argument, a copy of this particular argument is a copy of this particular variable is passed to the method argument. It's not the exact same variable. We are not passing the same reference of I here. We are passing a copy of it, a unique local copy of it. That's why whatever you do with I inside this particular method is not going to change the state of I which is defined here, because it is passed by value, or in simple language, the object is copied over locally to the method. It's not the same reference which is being passed upon. That's why you see this value. If you want to get the return value, then the one way is to just change the return type and say return I, and then just store this return I value here, saying int result equal to whatever is returned from here, and we are returning the new I here. And then you can print the result and you will get 2. If I run this now, I get I as 2. So this is just to validate that this is everything in Java is pass by value. There is no concept of pass by reference when we talk about method calling in Java. Let's take a more complicated example. This was a simple variable. Let's go back to the student.java. So I have the student class here. Let's create some objects of it and try to follow the same pattern. So here I have created an object of the student class named John, age 25, address 23 East California. I'm doing some sysouts which are not really important here, but let me just uncomment this particular method. So here what I'm doing is I'm calling a method. I'm basically defining a method which says change name in the same object, and I'm supplying the student object. So the student object gets here, and then I'm overwriting the name in the student object. That's what I'm doing here. So now let's just call this particular method and see what happens. So I'm going to call this particular method here and pass the object John inside it. And then let's try to print the name of the object referenced by John. If I say get name. So I'm calling this particular method, passing the John object here, where I'm overwriting the name John with Jane, and then I'm printing the new name of the John object. Let's see what happens now. So if I run this particular program, yes, I can see that the name has been overwritten from John to Jane now. This happened because you passed the reference pointed to the object inside the method, and then you overwrote the name on the object which was pointed by this particular reference. So here you might think that this is passed by reference, but this is still passed by value, because this reference is not the same reference as this one. This is a different reference, but both references are pointing to the same object. That is the only commonality here. So you can mutate a particular object inside a method, and be very careful of that. Do not ever try to do that, because it is going to create a lot of unpredictable results for you, because it might be possible that you're calling a particular method from some other application which is doing a lot of changes in the same argument object which you supplied, and then you don't know what is the state of it. So it's a very dangerous pattern and very dangerous way to mutate the objects. Do not do this. Let's find another way to deal with this problem. If I don't want to mutate the same object, how do I solve that problem? So we can solve that problem simply by creating a new object and changing whatever we want to change. So I have one more method here which says change name in a different object. It is also accepting the student object, and then here it is creating a new student object, and here it is overwriting the name but getting the age and the address as the same values from the argument. So we keep the age and the address same, but we create a new name, but we don't overwrite the same object. We create a new object, and then we can return this particular new object if we want to. I can do clear this, and I can say return new student, and then I can store the value of this particular method calling. I can call this method here, supply the same argument as John, Let me comment this one. And then I can store the value of the result, student result obj, and I get the value here, and then I can say result obj.getName. And if I run this program now, remember I'm calling a different method now, which is going to create a new object and then change the value. I do get the same effect, but now my previous object John is not touched at all. It is safe and sound. I can reuse this John object anywhere in my method, in my application, and I can be assured that nothing is changing in terms of the state of the object. So always follow this particular pattern whenever you are calling methods and passing arguments to the method. And if those arguments happen to be your custom classes and even Java classes, in fact, then always try to create a new copy of the object inside the method if you intend to mutate or change the state of the object. And let's get started with exceptions in Java. Let's first understand what are exceptions and why do we actually need this concept. The simple reason for having exceptions existence is that developers make mistake. We do create bugs and errors while we write code. It's natural. It always happens that whenever you write code, you might miss out some condition or the other, which creates a bug in the application, which creates a defect in the application. And then the testing team finds that defect and then we fix that defect. And that's how a normal software development lifecycle works. So to handle those kind of exceptions and errors, every programming language provides their own exception and error framework to support the developer in spotting those errors and fixing those errors and handling those errors instead. And Java also provides its own exception framework. So what you see on the screen right now is basically a snapshot of the exception framework of Java. And you see it has a long hierarchy of different classes here. This is also an inheritance hierarchy, just to give you context. And the whole exception framework hierarchy starts with a class called throwable. So throwable is the class which is the root or the parent class of handling all types of exceptions and errors. And that's where the next differentiation comes, exceptions and errors. Java treats these two things differently. And I will go in detail as to what is an exception and what is an error. But let's first understand the hierarchy further. Under the exception hierarchy, you see some exceptions like IO exceptions, which is an exception which comes when something goes wrong in the file writing or file reading or the file handling operations. Then you have SQL exception, which comes whenever you are talking to the database, writing SQL queries and something goes wrong. You also have class not found exception, which comes when a class is not found in the runtime or at the time when the class is being loaded in the JVM. And then you have also runtime exceptions, which are like arithmetic, number format, and there are lots more of this type of exceptions as well. On the right hand side, you have the error type, and then you have some errors like JVM error, memory error, and framework error. So now coming to the differentiation between exception and error. Exception is a type of problem which can be recovered in a program, from which the program can be recovered, which the developers should handle. So exception is a type where the developer focus is. The developer is responsible to make sure that none of these exceptions occur in the program. And if these exceptions occur in the program, then the developer has the responsibility to handle these exceptions properly. We will look at the examples of how the developer can handle these exceptions. On the right-hand side is the error type, where the developer does not have any control. You cannot do anything if the JVM has an error, or if the underlying memory of the computer or the JVM memory gets an error, or the whole framework or the Java itself, library itself has an error. You can't do anything about that. And those are the kind of problems which go into the category of error. That's why Java has created these two different categories. One is exceptions, which is the responsibility of the developer, and other is error, which are not the responsibility of the developer. And in fact, developer cannot do anything if this happens. So this was a quick tour to you to what kind of the exception framework is present in Java. Do read about this framework in detail in the Java docs as well. But just to extend this understanding further, we'll have a look at some examples of the exceptions and how these exceptions occur. So with that, I'm going to switch to the Eclipse IDE, and I have created a bunch of classes to show different types of exceptions. So let's go through the first class, which is named as Simple Exception Demo. It has a main method. It has a variable of int type. The variable name is data. And what I'm doing here is I'm dividing 100 by 0. So if you see this carefully, you know that this is going to result in an infinite value. You cannot divide any number by zero. And Java also prohibits doing the same because it doesn't make sense to divide anything by zero. So if you run this particular line, if you execute this particular line, this is going to throw a runtime exception. These are the runtime exceptions, remember. So let's try to comment rest of the code and let's quickly try to run this. So I run this program and there you go. I get an exception which says exception in the thread main. Main is the main thread. Which the exception type is java.lang.arithmetic exception. And this is the exception type, divide by 0. And it will also give you the line number at which the exception happens. If you click on this, it will directly take you to the exact line at which the exception happened. And this is, if you see now, this helps the developer a lot. This information which is printed here is called exception stack trace. And you can look at the stack trace, go to the last line, and this would be the line from where the exception actually originated. If you click on that particular line, it will take you exactly at the place where the exception might have occurred. And then you can look at the line, fix the code, and rerun the program to see if the exception is gone. That's why I said that developer has to handle this exception. Now, as far as handling these exceptions is concerned, I'm going to cover that in the next session. But in this particular session, we are just going to focus on the types of exceptions and how they occur. This was an example of arithmetic exception where we are trying to divide something by 0. Let's take another example. Let me uncomment this particular line of code and comment back this one. So here I am creating a string A, but the string is null, and null means nothing. It's a void reference. It has nothing in it. And now if I try to do some operation on this particular string, so remember A is null, and whenever you are trying to operate something on a null object, Java is going to throw you an exception because you can't operate on null, because null means nothing, empty. It is a dummy thing. So you cannot do anything on this particular null reference. And if I run this program, I get an exception which says null pointer exception, java.lang.null pointer exception, and it will give you the exact reason. Cannot invoke string.char at int string dot, this is a string type, string.char at int because A is null. So it will give you the exact reason as to why this program failed. And then again, if you click on this particular line, it will take you the exact line where the problem is. And then you can fix the problem. Maybe you need to initialize the string properly to make sure that this error doesn't occur. So these are all the runtime exceptions which the developer has to take care of, which the developer has to fix to make sure that the program runs smoothly. If they don't handle it, the program is going to fail, and the program will actually force them to fix because the program will not run unless they fix those exceptions. Now, these are the examples of runtime exceptions. You can also create these kind of exceptions, which are called checked exceptions. Runtime exceptions are also called unchecked exceptions. You might hear this term as well. Some people use the term runtime exception instead of unchecked exception and use both of them interchangeably. So runtime exceptions are also called unchecked exceptions, and these exceptions are called checked exceptions. Why do we call them checked and unchecked? Is because these exceptions are something which you do not have to explicitly specify in your program. In this program, I did not have to explicitly specify this particular because I don't know if this line of code is going to result into a null pointer exception or not. But these exceptions are something which Java will force you to handle. Let's look at an example of this. So I have created one more class which is named as checked exception demo, and I'm doing some file operations, basically reading a file, writing to a file, etc. I'm using some classes of Java named as file reader and some methods like readLine and close. And if you see, the moment I'm trying to read a file, this line has a red marker. There's a compilation error. If you scroll over it, it says unhandled exception type file not found exception. So Java is forcing you to handle this particular exception because file not found is a checked exception. So if your expression, your line of code is throwing a checked exception, then Java will force you to do something about it. It will not compile the code until you either handle this exception or you rethrow this exception. Again, how do we handle this is something which we will cover in the next session. But you can always rethrow this exception, but you have to do something about it. You cannot just skip it. So what I can do if I don't want to handle this is I will pass on the responsibility of handling this exception to the callee program. So whoever is going to call this main method has the responsibility now to handle the file not found exception, because I've just thrown it, I've just passed it on, I've just passed my responsibility to the callee. And you can do similar thing here as well. If I go here, you see it says unhandled type exception, IO exception. And if you remember, IO exception is here, it is a checked exception. So I can do one more throws here, comma V. And now if I just resolve the import, whoever is calling the main method has the responsibility of handling the file not found or IO exception. You can also handle it like I said, or you can just add throws clause to the method signature, and then the caller has the responsibility to fix or handle the exception. So this is how the checked exceptions work. Remember, in the unchecked exception, in the runtime exception, we can see that these two lines do throw exceptions, but there is no forced way by Java to tell us that I have to fix it, because Java doesn't care about unchecked exceptions at the compile time. It will only encounter those runtime exceptions at the runtime. That's why they're called runtime exceptions. But checked exceptions are compile time exceptions, and you have to fix them, handle them, or throw them right at the time of compiling the code. So that was about checked exception. Now there's also a possibility that you can create your own exception if you want to. And let's get started with exception handling in Java using try and catch blocks. So we had a look at the scenarios where an exception can occur. How do we see that there's a runtime exception, or there's a checked exception, or there's an unchecked exception, or there is a custom exception? Now, we did not talk about how to handle those exceptions. And now we are going to focus on the handling part. So whenever you have to handle those exceptions, the way Java provides for that is using the try catch block. So try catch block is basically a bunch of syntax which you have to follow to handle different types of exceptions in your programming code. And the syntax of the try catch block is pretty straightforward. You write try and you put curly braces, and then you write whatever code which might throw an exception. You don't know that, but it's always safer to enclose your code in a try catch block, so that you know that if an exception occurs in the try block, then you can handle it in the catch block. So it's always considered a better practice to enclose your application code in a try catch block so that you can handle the exceptions. So you put this try block and write all the suspicious or non-suspicious code which may or may not throw an exception inside the try block. Once you have done the try block part, then comes the catch block part. So let me go to the catch block. So this is how the syntax look like. Once you have written the try block, then you write catch and you put braces and you write the exception type which this block of code might throw, or the exception type which you are interested in catching. You might not be interested in catching all the different exceptions, but only a few ones based on your business requirements. So whatever exception type you want to catch, you are going to catch it like this. And if an exception occurs in the try code, let's say you have specified an arithmetic exception here, and if any line of code in the try block throws an arithmetic exception, then this catch block is going to catch that exception. And then inside these curly braces, you can decide what to do with that exception, whether you want to log that exception, or whether you want to rethrow that exception, whether you want to embed some error code or get an error code out of it, or convert that exception into a business or custom exception of your own choice. So it's up to you what you want to do with that. But catch block will be able to catch that arithmetic exception. Similarly, you can specify as many exception types to be caught as you want and keep adding more and more catch blocks. Remember that these catch blocks work in a sequential fashion. So if an exception occurs here, it will first go to this particular block to match the exception type. If it didn't match, then only it will move to the second type. If it did match the first type, it is not going to execute the second type. So that is how the try catch block work. You can see an example here that if the code here is throwing an index out of bound exception, then it is going to be caught here. And we are just printing the index out of bound exceptions message. If it is throwing an IO exception, then I can do this. So you can keep adding different checked and unchecked exceptions in the catch block. You can also catch more than one type of exception with one exception handler. So rather than writing these multiple catch blocks individually, you can combine these exceptions together if your logic of processing both of these exceptions is the same. Remember, if the logic of processing these two exceptions is the same, logic means whatever you write inside these curly braces. So if that code is going to be the same for both of these exceptions, then why bother writing two catch blocks? Just write one catch block like this. Use the pipe operator to separate different types of exceptions and write the common code which is going to be applied if your try block is going to throw an IO exception or an SQL exception. So that depends upon you. That's the second piece. The third piece of the try block is the finally block. So we talked about the try block, we talked about the catch block. Now there's a finally block as well. Remember, this is finally and not final. The finally block is used together with the try catch block when you want to perform some cleanup operations. Imagine you are opening up a file handler in the try block, you're doing something with it, and then you want to just close the file handler irrespective of the fact if there was an exception in the try block or not. Because even if there was an exception, the file handler resource is going to remain open and is going to consume memory in your application. You don't want to do that. Similarly, if you opened a database connection inside your try block, irrespective of the fact of what happens in the try block, you always would like to close the database connection. And you can write that closing code in the finally block. That's the purpose of the finally block, that you can write the code inside the finally block, which is supposed to be always executed irrespective of the fact whether an exception occurs or doesn't occur. So now we have built a good understanding of what is the try catch, what is the try block, catch block, and the finally block. Now, if you just put it all together, this is how it is going to look like. That you write the try block, you do something inside the try block, then you write the catch blocks. After that, you write the finally block. You can write the finally block without the catch block as well. Remember that. If you do not have any exception to catch, but you have some resources to close or free up after executing the try block, you can skip the catch block and just write try finally. That is also possible. With that understanding, let's switch to the IDE and let's look at some example. So I have a writer helper class, which is having a method called writeList. I have a try block here, and this try block is basically initializing an array list, adding an item to the array list, and then I'm accessing list.get1. Remember when I added this particular value, let me make it 10 to make it more understandable. When I added 10 to this particular list, this goes to the index 0 position. And here I'm trying to access index 1 position, which does not have anything. So in such case, it might throw an error because there's nothing at list.get1. So this is my method where I put the try block code. And then because I don't want to end up in a position where I get an index out of bound exception. Index out of bounds exception comes if you are trying to access an index which is illegal, which does not having any value. So I'm putting a catch block and catching the index out of bound exception and just printing the message of the exception. And then for simplicity, I'm showing a finally block as well. Though I do not have any resource to close here, but this is just to show you how this looks like in the code. This is just to show you that I'm printing a sys out here. This is what my method is. And if I go to the main class, the try catch demo class, I'm creating an object of the writer helper class and calling the writeList method, which we just walked through. Let's run this program and see what happens. Okay, so first I get this statement saying entering try statement. So if I go here, I call this method, the execution goes inside the try block and I get this sys out, which says entering try statement. Then I try to access the second element in the list because the position is 1. This is going to index 0 and I'm trying to access index 1. There is nothing at index 1. So I get an error saying index out of bounds exception, index 1 out of bounds for length 1. Because the total length of the list currently is 1 because there's just one element and that one element is sitting at 0 and not 1. So I get the exception, which is the index out of bound exception, but the index out of bound exception is caught by my catch block and the system.error.println is something which gets executed and I get this particular line from this line number 17. And then irrespective of the fact whether an exception occurred or not, my finally block always gets executed. Let's fix this and see if the finally block gets executed even if there is no exception. So now I'm accessing get 0 and let's see what happens. Yep, I access the element 10, no exception, but the finally block still gets executed. So this is to assert our understanding that the finally block will always be executed irrespective of the fact whether there was an exception or there wasn't. Now you can also nest different try blocks if you want to. Let's look at an example where I have multiple try blocks. So you can write a try within a try within a try if you want, and you can go as deep as you want. But remember, the more indentations, the more hierarchy you create, the program is going to get more and more complex. So always remember to have that kind of trade-off. So I write multiple try blocks, I initialize an array, I print array 10. Obviously array 10 does not exist because this array has just 4 elements. So this is bound to throw an index out of bound exception, and I'm catching that exception immediately in the catch block. This is the exception, printing a sysout and just rethrowing the exception. You can also rethrow the exception by just using the throw keyword. Remember, this throw is different from the throws keyword, which comes in the method signature. This is just to throw any exception from your code. So this is array index out of bound exception for this try block. Then I have another array index out of bound exception for this try block, which starts from here, block 2. And then I have another catch block for the block 1 try block. So you can see it is already getting a bit complicated where I have multiple hierarchies, but you can do that. So this is what is happening in this particular program. Now let's try to run this and see what happens and try to decipher the output. Okay, so at first I get this particular line which says array index out of bounds exception in block 3. What happens here is that this line gets executed. It throws an array index out of bounds exception. At line 13, that array index out of bounds exception is caught, which was generated from this line. And then we go inside the catch block. We execute this sysout. This is what you see here, the same sysout, and then we rethrow the exception. If we rethrow the exception goes to the enclosing try block. The enclosing try block is this one. There was an exception rethrown from this try block, and now it has gone to this try block. And now this try block, block 2, will try to see if it can catch this array index out of bound exception. Yes, we can catch it. So it can, so the block 2 again has a catch block which catches the array index out of bound, and it prints a sysout here which says exception in block 2, which we see here, and it again rethrows the exception. And if it rethrows the exception, so now the block 2 is rethrowing the exception. So this whole code is now rethrowing the exception. If this block 2 is rethrowing the exception, it goes to block 1, just going one hierarchy up. And then it sees if it can handle the exception in the catch block of this block 1. So yes, the block 1 try block also had a catch exception which said array index out of bound E4, and here it just had a sysout. So if I just bring back the output, yes, we do get this particular exception printed here which says array index out of bounds exception in block 1. This is what you see here. And this is where the exception just stops going propagated because I'm not rethrowing the exception from this particular catch block. So that's where the exception ends. The reason you see a hyperlink here is because the text which I have printed here exactly matches with the name of the exception. So Java is pretty smart in that case. If you use the exact same name exception, it will link it to the matching class name in Java, which is pretty cool. I also have a redundant catch block here, which does not have a try block. This is just to show you that you can write a catch block without a try block, but it doesn't make sense. It is of no use. So I can just remove this particular catch block and the program still will compile fine. So this was a quick demo to show you how you can use try, catch, and finally blocks. And when would you use the finally block? And if you want, you can use a nested hierarchy of try blocks, and you can rethrow the exception from within the catch block only to be caught in the outside or the outer or the enclosing block. And let's get started with equals and hash code in Java. This is probably one of the most important and interesting concept in Java and extremely popular when it comes to Java interview questions. So let's cover this in detail. To understand why we need equals and hash code and what equals and hash code is all about, let's first understand the object class of Java. Remember, I'm calling it an object class and not just an object. Object is a class as well in Java, and it is the super class of any class you create in Java. So anything you do in Java, any class you create, it will automatically be inherited by the object class. Object class is the super class of any class created in Java. And if you look at this documentation, and if you come here, you will see that object class defines this equals method, which indicates whether some other object is equal to this one or not. And it also defines a hash code method, which returns a hash code value for the object. So let's understand both of them one by one. First of all, let's establish that these methods have their concrete implementations available inside the object class. But how do you do that, and how does it come into effect? Remember when we talked about hash set, and I said that hash set will maintain uniqueness automatically. How does it maintain uniqueness automatically? It is because of the equals method implementation, which it inherits from the object class. That's how it maintains uniqueness. And if you remember, I also told that you can maintain uniqueness in a hash set if it's a built-in data type like integer or string or float or double, etc. But what if you are trying to create a hash set of student objects? Then Java does not know how to perform equality on two student objects because student is a custom object. Java doesn't know how to run equality. And that's where equals and hash code comes into picture. So the contract is that whenever you are creating your own custom objects and you have a need to perform equality on those objects, you must override the equals method in your own class. You have to override that. If you do not override that, then two student objects will be compared based on the reference and not based on the actual object values. We will see all of that with the help of an example. Another thing which says that whenever you are overriding equals, you should also override hash code method. Reason is because hash code is also used in certain collections, and we will cover that in a while. But let's just focus on equals first. And let me switch back to the Eclipse IDE, where I have a student class. Again, it's a very familiar class which we have covered in other lectures as well. And I have three different properties here: roll number, name, and address. I have a constructor, and I have setters and getters. Now, if I go here and I create three different objects of the student class, you see I have created three different objects. This student object has a roll number 1, name John, and the address is the same one. Second object has a roll number 2 and the name John, and the address is the same as this one. And third one again has a different roll number, but the name and address is the same. It's a hypothetical situation. So let's do one thing. Let's make this roll number as 1 as well. So now these two student objects are exactly identical. So what happens if I compare John with John 2? By looking at naked eyes, these two objects look exactly the same. So John equals John 2 should return true. Let's run this program, but we get false. The reason we get false is because the default implementation of equals is being run on comparing the student objects, because Java still does not know how to equate these two objects. Why you are getting false? Because these two are different references. Java created a new memory location somewhere and put this object, created a reference John to it. Then Java created one more new object in this line and created a new reference John to. So these two different references are pointing to two different memory locations of the objects. Though their internal values are same, but their memory locations are different. That's why you get this particular value as false, because these are pointing to two different memory locations. And that brings me to the hash code contract. You need to override the hash code contract as well, along with the equals, to make sure that your equality runs perfectly. Let's go back to the student class and let's fix this problem, because we can see that these are identical objects. You don't want to store the same student twice in your database, right? So you need to fix this. So I go back to the student.java and I have commented this equals method, and let me uncomment this now. So what I do, that I override the equals method, and the equals method contract looks like this, where you supply an object which is a foreign object, and now you need to compare this foreign object with your current object of the student class, which is this. So at first you need to run this particular condition, which says, are these two objects, these two references, this reference and the obj reference, pointing to the same object? If they're pointing to the same object, then this will return true, and then we will say that the object is that equality holds true because both are pointing to the same object. So obj equals this. If that doesn't hold true, if this doesn't hold true, then it moves on to line 50 and it runs a condition saying that is obj null, or obj.get class is not equal to this.get class. Get class is a method which will tell you the class type. Here we are checking is the obj class object is of the type student or not. If it's of different type, let's say vehicle or something, then definitely they will not be equal, and we can directly return false. So that's why I'm checking that it should not be null, or the class types should be matching. If these two conditions are, if either of these conditions are holding true, then I return false and I say that objects are not equal. So I've covered this condition where both of the references are pointing to the same object. I covered this condition where the class types were not matching or the obj itself was null. Then we return false. If we passed all of these sanity checks, then we do the actual comparison. Before doing the actual comparison, I need to do this explicit casting. So I cast the obj object into the student type. If you remember, this is how we did the casting for other data types as well. Once you have converted this obj into the student object, then you need to define your own business logic based on which you are going to define uniqueness. So how are you going to uniquely identify a student in your application will govern this logic. In this particular example, I'm saying that I am going to identify a unique student based on its roll number. So even if two students have exact same matching details, but if their roll numbers are different, then these are two different objects for me. But if two objects are having the same roll number, and even if they have a different name and address, I'm going to say that those two objects are duplicate. So roll number is the condition on which I'm defining uniqueness, equality, and duplicity. So I define this and say if the roll numbers are equal, then the object is equal. Objects are same basically or duplicate. And if the roll numbers are different, then these two are different objects. Good so far. Coming back to the main class. So now I have the same roll number here. Let me change the name just for fun and address as well. So I have a different name and a different address, but the roll number is exactly the same. Remember, we have defined the equality condition based on the roll number. And here we are comparing if John is equal to John 2 or not. So let's run this program. Now I get true. The reason I get true is because this equals method is used to run this equals comparison. So this establishes how we can use the equals contract to maintain uniqueness. Now I also said that whenever you are defining the equals method, you also have to override the hashcode method. And to understand why do we need hashcode as well, let's go back to how hash map works. Remember in the hash map, or let's say even hash set, in the hash set you have to maintain uniqueness. Now Java maintains uniqueness using both equals and hashcode. Hashcode is nothing but a memory bucket in Java's memory where your object is stored. It's basically a memory location. So every object has a hashcode, and that hashcode is the actual memory footprint where the object is stored. And whenever you are dealing with hash set or hash maps, you will be required to override both of these methods. Let's understand how this works. So if you have a hash set and you are trying to insert an element, then first Java will use your equals method definition to check if an object similar to the object being inserted is already present in the hash set or not. If it finds an object, it will basically flag that this is a duplicate object and it will not insert it. Let's understand how an object is fetched from hash set. Let me open a hash set example just to give you some sort of a visual representation of what I'm talking about. So if I go to my hash set example in the collections package somewhere, and let's open a hash set demo class. Yeah. So when we were doing these insertions, though this was a string object, so it was the Java already knew how to use the equals and hash code of it. But if it was a student object and you were doing multiple add, and then when you were actually fetching the element or you were doing the contains, then how does it work is basically first it is going to calculate the hash code of the object. Let's say you are saying hash set.get b or hash set.get John1. Then it is going to calculate the hash code of your John1 object. Hash code is your memory footprint, and hash code, and the way it is going to calculate the hash code is going to be based on the definition which you have provided. So the definition which you have provided, this hash code will be run to calculate the memory footprint, and then that particular Java will go to that particular memory footprint and see if there is an object present there or not. Now Java has a memory location, right? And there can be multiple objects stored at that particular memory location. This is possible in Java. So if there are multiple objects present in that particular memory location, which was calculated based on your hash code implementation, then Java is going to run the equals method to find the exact matching object. So just to try to visualize this, if I try to visualize this, let's say you have this memory locations, and let's say your hash code came up to memory location 2. And then at 2 memory location, you had multiple objects, obj1, obj2, obj3, etc. This is possible. Multiple objects can point to the same memory location. So if this happens, then Java is going to use the equals contract to compare your John1 object with obj1, with obj2, and with obj3. This is where the equals will come into use. So you see that both hash code and equals are being used here to point to the right memory location. And that's why I said that hash set and hash maps are where equals and hash code will come in full force, where you will be required to implement this. And it's a good practice to always override the equals and hash code in your application whenever you are creating classes. The reason is that you don't know when and where these classes will be stored into a hash set collection or a hash map collection. So it's always a good idea to have equals and hash code being implemented. And when you implement hash code, the thumb rule is that you should use the same parameters which have been used in the equals contract in the hash code contract as well. The reason for that is, what if you used here, let's say you used name here and you used roll number here, then two different properties are being used to find memory location and the uniqueness. And remember this logic which I just gave you. Here both hash code and equals are working together to find the right object. So if you make any mistakes in defining the equals and hash code, or if you made any mistake in defining the symmetry between equals and hash code, then you may get unpredictable results. How you define your hash code? Up to you. But make sure to use the same properties which you have used to define the equality. Always keep this consistent to avoid any unexpected results. You can also do this, just say return 1. And what will happen that when you use this particular student class in a hash set, all the objects are going to be stored at a single memory location. And then this particular situation will occur where you will have a single memory location and all of your objects will be present at that memory location. And when you are trying to fetch anything, the hash code will always point to the same memory location, and then equals will make sure to find out the right object you are trying to fetch from the hash set. And let's get started with comparable in Java. And before we go there, let's understand why do we need comparable. The need for comparable comes from the requirement whenever you have to sort your collections. So to understand that, let's move over to the Java docs to understand how this works. So the basic idea is that you want to sort your collection, and to do that, Java provides you with a method called collections.sort. You just supply your list or your collection inside this sort method, and all the elements or objects inside your collection will be sorted based on the natural sorted ordering. This holds true for built-in data types, but what if your list is of type student objects? Then again, the same constraint applies that Java does not know how to sort student objects. It knows how to sort strings and ints and floats and doubles because those are built-in data types, but student is your custom type and Java doesn't know how to sort it. And to solve that problem, Java provides an interface called comparable. So comparable is the interface which you need to implement from your class whenever you have a need to sort your objects of your class type. So this is the interface which your class needs to implement. This interface provides a single method which says compare to, and it provides the foreign object, and then you need to compare this foreign object with your current object. So let's go back to the Java class and understand how do we work with this comparable interface. So again, I have used the student class for the sake of continuity, and I have the same properties as roll number, name, and age. But this time I say implements comparable of type student. This is a generics type. We will be covering generics in a bit more detail in this whole series. But the basic idea is that to define that this comparable interface will only work for student types. You define the type in this particular construct, which we also call as generic type. So you do this, and the moment you do this, Java will force you to provide the implementation of the compare to method, which I have provided here. So the way this implementation works is you have a foreign object here, but this time this foreign object, since I have defined this as of type student, so the moment you do this, Java will ask you to override this method, and using Eclipse Ide, if you override this, then you will get this signature automatically. Let me show you how this works. So if you do this, you will get an error here. And if you click on this balloon, it will say add unimplemented methods. If you double click on this, you will see a compare to implementation here. And this is exactly the skeleton which you see here. By default, it says return 0, but I'll just come back to that in a while. So this is how this method came up here. And once you have this signature available, then you need to provide your implementation on how do you want to sort the objects. remember you need to define your logic here. So again, I would like to sort my students based on the roll number, which is the natural sorting order for me for the student objects. So this is your custom sorting logic, which you can call as natural custom logic sorting order for your student objects. So I want to sort them based on roll number, but you see I've done a strange thing here. I've done a minus here. So what I'm doing is that the current object's roll number minus the foreign object's roll number. So if this value comes as a positive number, then this object is going to take priority. This is going to be sitting before the student. If this result returns in a negative value, then this object will come first and this will come second. So the student object will come first and this object, the current object, will come second. And if this returns 0, then it means both of the objects deserve the same priority or the same order priority, and any one of them can come after the other. So the basic idea is that if this results in greater than 0, then the current object is going to take precedence. If this is going to return in a negative value, then the foreign object which you're supplying here is going to take precedence. And if this returns in 0, then any one of them can take precedence. So you need to define your compare to logic in the compare to override implementation. Once you have done that, let's understand this with the help of an example. I've created a comparable demo class which has a public static void main method, and I create an array list and I create 3 different student objects. First student object is named as John, second is Jane, and third is Tom. The first has a roll number of 3. So John has a roll number of 3, Jane has a roll number of 1, and Tom has a roll number of 2. So if my compare to logic runs perfectly, then Jane should be coming first after I sort this collection, after I add these 3 elements into my list. And once I sort this collection, then Jane should come first, Tom should come second, and John should come third, based on my natural ordering custom logic, which I have implemented in the compare to method. And that's what I'm doing here. After I've sorted the list, I'm just printing the list by using the for each construct of the streams API. I'm just printing the name to see which one comes first and which one comes second. So let's run this program. And this is how it looks like. So Jane comes first because she had a roll number 1. Tom came second because he had a roll number 2. And John came third because his roll number was 3. So no matter how many times you run this program, you're going to get the collection in the same sorted sequence. And this is happening because of the compare to implementation which you provided here. Now, if you comment this implementation, let's see what happens. And I remove this implements comparable as well from here. I just create a simple student class and now I try to run this sort. Now you see that you get an error here. And if you hover over this balloon, it says that the method sort in the type collection is not applicable to the argument array list of student. Java does not know how to sort this. So it will force you to provide a sorted implementation. And the moment you provide comparable implementation here, and if you go back to the main class, the error is gone. So this also will force you to provide your comparable implementation. Now you can use this sorting for any kind of collection sorting as well. And whenever you are doing this, always make sure to provide the compare to implementation. And remember that contract which I gave you about greater than 0, less than 0, and equal. And let's get started with comparators in Java. We talked about comparable, where we said that whenever we want to implement a naturally occurring sorting order, where you just say collection.sort and you sit back and relax, if you have provided the compare to implementation, you would expect things to work. But what if you have a custom sorting requirement? Let's take a hypothetical scenario where you created an application and your application has a student object and you created a collection of student objects, and now you have different consumer applications. Let's say you have a payroll application, you have an attendance system, you have an examination system, you have another extracurricular activity system, and all of them want to get the student collection, but all of them have different sorting requirements. Payroll wants to have the sorting based on the roll number. Attendance want to have the sorting on some other mechanism. Extracurricular application want to have the sorting on some other mechanism. So how do you implement custom sorting or multiple sorting logics for your collection? And that's where comparators comes into picture. Comparator is again an interface, as you can see here in the signature. And this interface provides you the flexibility to define your own custom sorting logic multiple times. So you can create multiple comparator implementations, and each comparator implementation will focus on a particular sorting order. So that's the basic need of sorting. So remember, whenever you want to sort the object in an order other than natural ordering, or you want to sort some object that don't implement comparable. So whenever you have these kind of conditions, always think of comparator. Apart from that, always think of comparator when you have to provide multiple sorting implementations on the same collection. So let's see how can we do that with the help of an example. So here again, I have the same student class and I have the same properties. Currently, by default, I have provided a comparable student implementation, which is exactly the same as we covered in the last session. And if we use this particular implementation, we create an array list, we created multiple student objects, we added them to the list, and we called sort. So what happens if I just comment the new code, and if I just run this particular code, remember the sorting is happening on the roll number. So here, roll number 1, Jane will come first, roll number 2, Tom will come second, and roll number 3, John will come third. But then you had one more application which wanted to have the sorting based on the age of the student. So these are the age values of the students, and some application wants you to provide the sorting implementation for the age. Now, age is a custom sorting logic which you need to provide. And whenever you have that kind of situation, create a comparator. How do you create a comparator? Like this. Simply create a class, name your comparator anything, try to end it with the suffix comparator so that you know that this is a comparator implementation. And then you say implements comparator of the class type. This is what you need to do. And the moment you do this, it will force you to override this compare method. Remember, the comparable interface provided compare to method where you supplied just the foreign object. Its name was compare to with single object. In comparator, the name is just compare, and you have two objects here, student 1 and student 2. Let me just call them student 1 and student 2 for simplicity. O1 and O2 look a bit weird. So I've just refactored this one, and I will refactor this one as well. So I have student 1 and student 2, and this is an age comparator. So I want to apply the sorting logic based on age. Simply put, whoever is younger should come first, and whoever is older should come later in the collection once I sort it. So let's see how this sorting logic is implemented. This is a single line code, so let me just put braces around it so that it's more easily readable. You can write it without braces as well if you have a single statement inside the if block or else block, but you can always write it like this. And let me just format this as well. Okay, so this is the compare implementation. The first logic which I've run which says that if the first student's age is less than the second student's age, then return -1. Similarly, if the first student's age is greater than the second student age, then return +1. And if both of the students' age are same, then return 0. So this is your custom logic, and this is where you need to define your logic. And remember, this will also govern whether the sorting is going to be ascending or descending. So for example, if you have provided that student 1's age is less than student 2's age, then return -1, then this is going to maintain the natural sorting or the ascending order sorting. Now, if you want to have a descending order sorting, just change these values, saying that if this is less, then return 1, and if it is greater, then return -1. And this is going to run the sorting in a descending order fashion now. So it depends upon what kind of sorting order you want, and based on that, you can define the values. But the default is always like this, that whenever the first object's value is less than the second object value, return -1. And if the first object's value is greater than the second object's value, then return +1, otherwise return 0. -1 means this one will get precedence over this one. So this is how you have provided your age comparator. Going back to the main class and uncommenting the other part of the code, here I have called the sort method where I want to sort the list, but since I want to supply a custom sorting operator or a custom sorting comparator here, I need to provide that comparator object here. So remember the age comparator which you created here, you just need to provide the comparator. You need to tell Java how to sort this particular list. If you do not tell Java how to sort this, Java is going to look for the comparable implementation in the student class, and it will sort the student objects based on the compare to implementation provided inside the student class. But if you want to have more custom control over sorting, then you need to tell Java how to do that sorting. And if you see, this is an overloaded representation. This is a method overloading example as well, where the method signature is same, but just the number of arguments are different. So this is how you provide your custom sorting. You supply your comparator. Now you can create multiple comparators. You can create another comparator based on, let's say, name. You can have one more property here, create one more comparator. So you can have as many comparators as you want. Just keep creating them and keep supplying them individually one by one in the sort method. You can just duplicate this and add one more comparator. So this is how you are going to have more control. And if you have multiple consumer application, call multiple sort methods, supply their corresponding comparator, and you will get the sorted collection. So here I'm just printing the list based on the age comparator sorting. And these are the objects. So let's see how this works and understand the output from the beginning. So the natural sorting order is something which we have already covered, which was done based on the roll numbers. So Jane comes first, Tom comes second, and John comes third. And this is how you get this particular output. Now coming to the age comparator, you print this particular statement, which is coming here, and then you print these values. So let's see how the age comparator is working. The youngest here is John. So John comes first. Then we have Tom, who is 20 years old. So Tom comes here. And then we have Jane, who is 21 years old, and Jane comes in the last. So we can see that our age comparator has fired here, and it has sorted this in an ascending order. Now let's flip the values. I'm going to change the values here, and now it should work in a descending sorting order for the age comparator. So let's run this application again, and now you see Jane comes first, who is 21, then Tom comes, who is 20, and then John comes, who is 18. So now the age comparator is working in a descending order. And let's get started with enums or enumerations or enumerated types in Java. So before we go into enums, let's understand why we need it. When you will be building the Java applications, you will face scenarios where you will have to define some variables which will remain constant forever. For example, months of the year, they are not going to change. They are always going to be 12 months in an year. Similarly, let's say name of flowers, they are not going to change. A lotus will be a lotus forever. Similarly, the name of the seasons will always remain same. The season of summer or winter will always be called summer or winter. They will not be changed. The meaning of those variables will never be overwritten or will never be changed. So you can think of them as constants, but they are not the constants which your programs may mutate or your programs may interpret differently. They will be interpreted by multiple applications, multiple components, multiple consumers in exactly the same way. Similarly, if you take the example of time zones, they are fixed. They work with the GMT with respect to the GMT time zone, and they will always remain like that. So whenever you have a situation where you have to define such constructs or such constants, always think of enum types or enumerated types. Enum is basically a language construct, and you can use this language construct to define type safe variables. When we say type safe variables, what we mean is that these variables are not integer or string. They are of enum types. That's the reason Java created a completely new data type, which is called the enum type. They are by default constant, so you cannot change them. That's their property. And the way you define enums is like this. You say public enum. So instead of the keyword class, you use the keyword enum. And then you define the name of the enum type, and then you define the possible values, just simply separating them by a comma. So for example, days of the week is again a constant thing. There will always be 7 days of the week, irrespective of what you do on this planet. So that's why you can declare an enum for the day, and you can define those as the values. You also notice that the values are caps by default, and yes, that is how you define the enums. Let's have a look at a more interesting example of the enums in the IDE now. So if I switch to the IDE, I have created a class called color, not a class, but an enum type called color. And this enum type color is basically holding all the different color types. their values basically, like all the WebGear colors, for example. So I've defined three colors here, which are red, green, and blue. So you see, I've defined them as caps. They automatically become bold. You don't have to bold them. But you see an interesting thing, a difference here, that there is another value in the brackets here. This was not there when we looked at this example of day. There is no value inside each of the enum types, but I have defined the value of the enum types, and that is optional. There will be use cases where you want to define some enum constants, where the name of the enum type is a constant, which is a placeholder, but it will have an internal value, which may be more practical for your application. So this is what your consumers see, and this is what is used whenever you call red inside your application. Is just for simplicity. There might be use cases where you use some abbreviations and their full forms. For example, if you want to use here an abbreviation of, let's say, WHO, and inside this you can define the value as World Health Organization. So this is just a toy example I'm giving you, where you will have use cases where you want to define a constant, but you want to define an internal value of it, which is to be read by your application elsewhere. But everybody who wants to consume this enum can just use this particular keyword. And if they want to get the value, they can get the value as well. So this is the use case where you might need to define values of your enum types as well. But whenever you have to do that, if you want to fetch the value of an enum type, you have to write some extra code which is written here. If you are not defining the value of your enum types, your enum can be as simple as this. You don't need to define anything else apart from just defining the constant of the enum types. I'm giving a more complex use case so that it covers both of the things of using just the constants and also using the values. So if you just want to read the constant, you can just say color.red or color.green or color.blue in different classes, and you will be able to refer to the enum types or use the enum types. But if you want to refer to the value of the enum type, then probably you need to call this method called getValue. So whenever you define a value, what you would do is you will define a private member variable inside the enum, which is defined here. You can name it anything if you want. You define a constructor where you set this particular value, and then you define a getter. So whenever some consumer application wants to refer to the value of your enum type, they can call this getValue method to get that. So this is the enum. Now let's see how we can use this enum. For using this enum, I have this main class where I have a public static void main method, and you can simply fetch the enum types by writing the code like this. Just write the enum type holder and then type the enum type. So let me show you how this is done. If you just put a dot here, you will get all the enum type options. So I've defined three enum types, red, green, and blue, and I get all the options. So whatever option I want to choose, I can just select here, and I can store this inside an enum variable. So if you want to just refer to the name of the enum, so this C1 is holding color.red or red. So if you want to refer to this, just this red, then you can call the dot name method on the C1 variable. So if you say C1.name, it is going to put or print the red in caps. And if you want to fetch the value inside the red, remember the value is red in small caps. So if you want to refer to the, or if you want to fetch the value of the red, then you call the getValue method, which we have defined here. So that's what we are doing here in this first two sysouts, where we are printing the red enum name and then printing the red enum value. Now you can also iterate over all the enum types. And for that, you need to call the dot values method on the enum. So you can just say color.values, which is going to iterate over all the enum types. And you are just storing each of the enum type in this color placeholder. Then you can either call getValue to get the actual value of that enum type, or you can call the name to just print the name of the enum as well. Both of the options are available. So let's just put it back to getValue and let's run this code. So if I run this application, I get some output here, which looks like this. First sysout says red enum name is red in caps because we are calling the name method. Second says red enum value, which prints red in small because we are calling the getValue method. And then we are iterating over all the enums. So I had three enum variables here, red, green, and blue. And I'm going to iterate over all of them one by one here, printing their value and not the enum constants. So that's why you see the red, green, and blue here in small. But if you just want to print the enum constants themselves and not their values, then you change this to .name, and then all the enum constants will be printed here. So this is how you can create enums and use enums for the constants which are never going to change in your application. And let's get started with annotations in Java. Now, annotations is a bit advanced concept, so let's understand why we need it. There would be some cases in your application where you need to provide some metadata information to the Java compiler. Now, this sounds a bit complicated, but it's much simpler than that, because you might not want to code everything with a lot of lines of code. Rather, you want to give some smart instructions to the Java compiler so that they understand what to do. We have already seen some of the annotations, but the basic idea of annotations is to provide some shorthand metadata information about the program to the Java compiler. Generally, annotations will not have any direct effect on the operation of the code they annotate, but they provide additional logic to the code. That's the idea with annotation. Remember, they are shorthand metadata. The main use is providing information to the compiler, or providing some compile time or deployment time processing, or also providing some instructions for runtime processing. We have already seen some of the annotations. If you remember, when we were dealing with inheritance, we had this @override over the methods, right? This @override is an annotation. This annotation, if I show you what I'm talking about, if I take you back to one of the inheritance example or the method overriding examples, and if I open the mountain bike class here, mountain bike extends bicycle, you will see this override annotation. This is an annotation. An annotation always starts with @ in Java, and the annotation name is override. Now, this override is just a shorthand to tell the compiler that, hey, I am overriding this method from the base class. That's what this annotation does. If you remove the annotation, in some cases, the Java compiler might not understand what to do, and the Java compiler has to do some extra processing to figure out that this method is actually being overridden. But if you put this @override here, then the Java compiler pre-hand will know that this is coming from the base class. So you save some of the compiler processing time as well by using the annotation. It's a shorthand providing instructions to the compiler. You see exactly what I'm talking about. So this is one of the annotations which we have used, but we will look at some of the other more generic annotations, and we will also see how we can build our own custom annotation in Java. You might have also seen some other annotations, like, for example, you can put @suppress warning annotation, which is a very popular annotation to suppress any kind of yellow warnings in your code. Generally, we do not recommend doing that, but if you have a use case, then you can use @suppress annotation as well. There are some other annotations as well, like @author. If you want to put your name as the author of a particular piece of code, then you can add this metadata so that whenever somebody looks at even the documentation of your code, your name will be shown there as the author. So that's the idea with annotations. So let's see how you can build your own custom annotation. Whenever you have to do that, there are multiple ways to doing that. And the first type of annotation we are going to have a look at is called marker annotation. A marker annotation is just an empty annotation without having any metadata logic at all. You can see I have defined an annotation here. I will talk about what all this means, but inside the block, there is no code here. And this is how you define a marker annotation. Marker annotation is just to provide very high level instructions to the compiler. And the way you will write your custom annotation is you will put an access modifier keyword like public. Then you will write @interface. This is the keyword which you have to use whenever you're trying to create your custom annotation. Marker or no marker doesn't matter. Whenever you define your annotation, you have to use @interface. Once you do that, then you provide a name for your annotation, which can be anything, but still not complete. You need to also provide more instructions to the compiler or the runtime processor to tell them when to execute this annotation and what the annotation type is going to be applied upon. So at first you specify when this annotation is going to be active or executed or evaluated. So here you can say @retention, which is another annotation. So you say @retention, and then you say retention policy dot whatever you want to write as. You can write it as runtime or you can write it as source. If you write it as source, then it is going to be applied at compile time. And if you select it as runtime, then the annotation is going to be processed at runtime. So this is the first thing which you need to provide. The second thing which you need to provide is where this annotation is going to be applied, whether you want this annotation to be applied to a class or to a method or to a member variable or to any other type. And that's what you define in the @target annotation. You specify the target audience for this particular annotation. And here inside the element type, you will get multiple options. You can apply this annotation to a constructor, to a field, local variable, method, module, package, record component, type, etc. So here I'm going to use type, which means it can be applied to a class or a generic element type, which generally means class type. And that's all. You can define your marker annotation like this. But generally these marker annotations does not have any logic, so you will not get much value out of it until you have very special cases. But if you have a case where you want to also run some business logic or provide some metadata logic to the compiler while defining the annotation, then you can define the annotation like this. So I've created one more annotation here, which is called my custom annotation. Again, the target audience for this is method. So this annotation can only and only be applied to methods. If you try to apply this annotation to a class, you will get an error. The retention policy is runtime. It means it is going to be processed at runtime. And I've declared a method here, which is called int value. So this is how you will declare your annotation. Now let's see how do you use this annotation. So I have a class called as my class here. And if you look at this structure of the my class, we create the class and then I create a method, which is named as say hello. And I am applying this annotation on this particular method. Remember, the target audience of this particular annotation was method, so it only be applied on method. If I try to put this on the class type here, then I get an error here. It says the annotation, my custom annotation, is disallowed at this location because the type specified is of type method. So the compiler will not allow you to use this at an illegal place. So you write any method and you apply your annotation, but you provide a value to the method. The int value method is going to consume this value. And inside the method, you can write any other logic. So let's see how this pans out. I create a public static void main method and I create an object of my class. So my class h equal to new my class. And after that, I'm saying h.getClass.get method. I'm basically calling the method by using reflection API. You can also call the method directly if you want, but this is how you need to call it if you want to use the annotation property value, if you want to fetch the value of the annotation. So this is just an example of me showing you how you fetch the annotation. So we created an object and then we say get class, which is going to return my class type, and then get method is going to return the method type, which has the name say hello. So this is a way to fetch a method name or a method type from a class using Java's reflection API, which is an advanced API. You might not need to use it, but for the sake of demo, I'm using this. So we fetch the class and we fetch the method. It is going to search the class for a method named say hello. If it finds the method, it is going to return the method in this variable. And then you can call method val, which was this variable, dot get annotation. Give me any annotation which is applied on this particular method. And you supply the annotation class type as well. Once you do that, you get a my custom annotation reference type. And then if you call the value method on this, you will get this value as 10. So this is a way where you can apply an annotation and you can actually see the effect of the annotation. You might not always want to do this because, like I said, these are metadata instructions to the compiler. But if you have a need to actually see what your annotation is doing, you can use the getClass.get method to first fetch the method, store it into a method type, and then call get annotation, supplying the exact annotation class type, and then you can call the exact method which is defined in your annotation. Here I've defined it as value, so I'm just calling the value method. So if I run this particular example, I get the value as 10. So I'm able to see or fetch the exact value which my annotation metadata is holding at the runtime. And this is the power of annotation. They're a very powerful concept and they're a very advanced concept. There would be very rare scenarios in your application where you need to create your custom annotations. Generally, you will be better off with your predefined annotations which are provided in Java, like @override, @author, suppress warning, etc. And let's get started with serialization in Java. Now, before we go further, let's understand why we need the concept of serialization. When you will be building the enterprise grade applications, in different organizations, you will often have a use case or a need to send an object from one application to other application which is deployed on some other machine. So if you have a network of computers, or if you have a lot of different complex setup where you have a producer application and you have a consumer application. Producer application produces the object, and then this object gets traveled over the network lines, over the network wires, and reaches at the consumer application. And how does the consumer application receive the object, and how does the producer application sends the object? Because when the data travels over the network lines, it will be all bytes. So how do you convert a Java object into bytes, send it over network, and then the consumer application has to again convert that bytes back to an object representation and then store that or use that inside its application. So you need to do this whole conversion, right? So the process of converting an object to a byte so that it can be sent over a network is called serialization. And the process of converting back the byte from the network to a Java object is called deserialization. So generally, you may have a use case where you serialize an object, create a binary representation of it, send it over the network. And that's where the Java serialization concept kicks in. Whenever you have to do this in Java, you will be using the serializable interface. So you need to extend your objects from this serializable interface so that those objects themselves becomes serializable. You need to tell Java that this object is able to serialize itself and deserialize itself. And the way you will tell Java is by letting that object implementing the serializable interface. Let's have a look at an example of this serialization and deserialization to understand this concept better. So here again, I've used the same student class where it has the name, age, and address. So you can see I have created a student class, but the student class implements serializable. This is something which you have to add to your class. Second thing, the moment you do that, all the modern day IDEs like Eclipse or IntelliJ will ask you to add a serial version universal ID to this particular class. This is added so that Java can uniquely identify your object once it is serialized and deserialized. And it will also keep a versioning track of it, right? Because when you serialize the object, what happens if somebody hops over the network line and change the representation of your object? And the consumer application will get a completely different object copy now. So this is Java's way to make sure that the same version which the producer application is producing is received by the consumer application. So it's also sort of a security feature. It basically, whenever you do an update onto the object, it is going to increment this serial version UID by 1. So when you create the object first time and you serialize it for the very first time, the value is going to be set as default 1. And as you mutate the object again and again, before deserializing it, the count will just keep on increasing. So that's how you keep a track of the state of the object which is being serialized by adding this long serial version UID. You can also specify your own value if you want to. By default, Java initializes a value of 1, and this is a long type variable. So that is the only new thing which is happening the moment you do implement serializable. After that, I have the same fields here. I have the constructor and the setters and the getters. And I also have a toString method just to print the object nicely, where I print the name, the age, and the address. So let's look at a main class and where we use the student object, we serialize this object, and then we deserialize this object. So what is happening here is I create a class, I create the main method, and I create a student object. This is something which we have already seen. Then I want to store the state of this object. When you serialize this object has to be either sent to a network. But since I'm running this demo on the same machine, what I will do that I will serialize this object onto my local file system. It's the same thing, right? You can put it somewhere and then fetch it from there. So either you can send it over the network or you can put it on a file system. So I create the object and then I need to store this into a file. So far, I have not covered the file handling operations. So we will not go deeper into the file handling classes here, but I will just explain you the reasoning for it. And when we'll do the file handling session, there I will go in detail about the file handling classes. So I specify a file name where the serialized representation of my student object is going to be stored. And this is the location where I'm supposed to store this. Then I create two different classes, which is for writing to the file and then creating an object for it. So that's what I'm doing here. We can ignore this particular part where I'm just supplying the file name, and we can focus on this part, this line, where I'm saying write the object, the student object, to this particular file. That's what I'm doing here in this 3 lines of code, that I'm writing the student object to the file. So when Java has to write this object to the file, it is automatically going to serialize it. That's the only way Java can write an object to the file. So you serialize the object, and then you print that message that the object has been serialized. Again, you can ignore this part as well. Like I said, we will not focus on this. But what we technically did is we just wrote the object to a file by serializing it. Then I try to deserialize it. So I load this same file into the Java JVM, and then I read the object. And the way I read the object is by using this object input stream class. I supply the file that read this particular file, and then I call the read object method, which is going to return an object, a general object. When you call the read object method does not know that it is a student type object. So you need to explicitly cast this to the student type so that you can store this as a student object. If you do not cast this, you will get an error, because like I said, read object does not know anything about the student class. So what does this mean is that when you serialize an object, the class type information is lost. You cannot store the class type information when you serialize an object, because the moment you call this write object method from the object output stream class, so you created this object output stream class, you supply the file output location, and you call the write object. The moment you call the write object, it's just any Java object for this Java program. The signature of the student class is lost. It does not know that it's a student class anymore once it is being serialized. Similarly, when you deserialize it, the serialization API has no idea about what student class is and what student object is. So you need to tell the read object method explicitly that, hey, you are reading an object of the student type. And that's how this line works. Once you explicitly provide the casting operation. Once you have casted it, we try to print the same deserialized object to see if all the state which we stored in the object is still persisted there or not when we deserialize it. So our major focus in this particular class is this object output stream classes and the write object method. These are the two most important statements which you need to take care of. The file output stream is basically a file location. What is an output stream? We will talk about that later, but whenever you need to serialize, you need to use this particular class called object output stream. So that's all I'm doing here. I'm serializing the object with these values, and then I will deserialize and I will again print the object to see if these values are still there or not. So let's run this application. So when I run this application, let's start from here. First, this sysout gets called, which says object has been serialized. So you see object has been serialized. And what I serialized was this student object, which had the value of name as John, age as 25, and the address as 23 East California. And that's what gets printed here. Then this whole block gets completed. This whole try block gets completed. It's a standard try catch block. You see, I have also added the IO exception. You need to do that because these file operations will force you to catch or throw the IO exception, which is a checked exception. That's why it will force you to do that. Then we move to the deserialization block, where we create an object of the object input stream class. And then we call the read object. We cast it to the student type, and then we print the object. So when I print this object, this line gets printed, object has been deserialized, and then I can see that the exact same state is still there. The name which I set in the object is still there after being deserialized. The age and the address is exactly intact. So this is how you can serialize an object, send it anywhere you want, and then the consumer application need to read the object and cast it back to the student type, and they will be able to see the exact same state which you saved in the object just before serializing it. What if you have a use case where you have a property in a student class or in your object, but you do not want that to be serialized? That's also a use case where you may have 50 different properties inside the student class, And one of the properties is something which you do not want to serialize because you do not want the consumer application to see that value. If you ever had that scenario, use the transient variable. So transient is again a keyword, and the moment you put this keyword in front of a member variable, that variable becomes transient. The use case of transient variable is that if you do not want this X to be serialized and deserialized, then you put the transient keyword in front of it. The normal member variables will automatically get serialized and deserialized when the object is serialized and deserialized. But if you have a use case where you do not want a particular member variable to be serialized or deserialized, put transient in front of it. And then have the getters and setters for this X variable. And let's use this and see if this actually gets serialized or not. So I created the student object and let me call student.setX. And let's put a value to X. Let's say 10. So I have set the value of X is 10 and X is a transient variable. And then I am serializing the whole object here. And then I'm deserializing the object. And let's see if I'm able to fetch the value of X after deserializing the student object. So I'm calling the system.out.println and the deserialized value of X is object.getX. Let's see if I'm able to see the value of X or not. So let's run this application again. So this is exactly the same as before. This is also exactly the same as before, but I see the value of X is 0. Remember, I set the value as 10 before serializing it, but I don't see the value 10 anymore when I deserialize the object because it was transient. If you remove transient from it, then you will be able to transfer or travel this value of 10 between serialization and deserialization. So if I just remove this here, don't change anything at all, and I just rerun the application, this time when I deserialize the object, the value of X as 10 is still present there even after deserialization. So this is how you can use the transient variables if you want to not have that object serialized or deserialized when you're doing the serialization. And let's get started with concurrency and threads. The reason I want to talk about concurrency because once we understand about the concurrency, it will become much more simpler to talk about threads. And the idea behind concurrency is very simple and plain. And that idea is that as a developer, when you write a program, you would expect the machine or the computer to run multiple tasks in parallel. For example, right now, I'm recording this video on a particular laptop, which is recording my voice, which is also recording the screen, which is also running the Eclipse Ide and also running a Chrome browser. It also have opened multiple background applications. So there are a lot of tasks running in parallel at the same time. And that's the idea about concurrency. Now, how do we work with concurrency in Java is with the help of processes and threads. So these are the two basic units of execution when we talk about concurrent programming in Java. And when we talk about processes, you can think of a process as basically an execution environment, or I should call it as a standalone execution environment. Think of a logical box which is completely cut out from everything and it has its own environment. For example, again, the recording software is running in its own execution environment. And when we talk about process generally has an everything or a private set of all the runtime resources it needs and the memory space it needs. Now, there's another concept or another construct which is very important is threads. So threads are also sometimes called lightweight processes. And basically, when we talk about threads, a thread also has an execution environment, but creating a new thread requires a lot less resources than creating a new process. And you can also think of threads as a mini version of a process because a process can have multiple threads. Remember that statement that a process can have multiple threads. Threads always exist within a process. And whenever you start a process, there will be at least one thread attached to it. And each thread is basically a task. For example, the voice recording can be a process, and inside that, the mic recording expression or the mic recording task can be run by a particular thread. Let's take another example that when you play games, let's say you're playing a racing game. So when you play the racing game, there are multiple things happening at once. You see the current speed of your car or bike on the screen. You also see your leaderboard position, what ranking you have in the race currently. You also see some other kind of features like player's health or the car's health or the fuel consumption available and lots of other stuff. The graphics, the motorcycle, the other competitors' bikes and their speeds and their distance to you as well. So if you see, all of these are running on different threads. There's a different thread to show your current speed. There's a different thread to show the current leaderboard position. There's a different thread to show the fuel indicator, etc. Everything is running in a different thread. So all of these threads need to run at the same time in your program for a complete immersive user experience. And that's what we mean when we say multi-threading, that we want multiple threads to run at the same time to create a better experience in the application. So that's basically the theoretical part of it. Please do read more about how threads work and how processes work. And there's a lot more documentation available in the Java docs as well when we talk about threads. But I will keep the theoretical part to this particular point. And now we will move to an Eclipse example to see how we can create threads. So with that, let's move to the Eclipse IDE. And here I have a demo prepared basically. So what I have here is a threading demo class, which has a public static void main method, and it has a simple for loop. And inside the for loop, I see this strange code here where I am initializing two threads and starting them. So that's all I'm doing here. But let's see how this thread1 and thread2 class have been written and why do I see two different ways of initializing them. Let's go deeper into this now. So let's see how thread1 can be created. So first of all, you can create a thread by just creating a simple class, but make sure that you extend it with the pre-built thread class. This thread class is coming from Java. So from the JDK basically. So the moment you extend your normal class from the thread class, then you will have to override the run method. So if I show you the thread class here, this is the thread class implementation available inside the JDK. And this is the class which is getting called when you are extending it from the thread class. And this thread class will ask you to override a run method. Here the override annotation is missing. So let me just add this for better understanding. So you need to override the run method. And this is something which you need to do so that you can specify what happens when you run the thread. So this run method will be called whenever the thread is running. At this particular point, I would also like to tell you that there are different states in the thread. So there is a thread which says thread is ready. Then there is a state which says thread is running. There is also a state where the thread is waiting for an IO input from the user from the console or the command line. There can also be a state which says dead, where the thread has completed its task and it's not working. There can also be a state which is called sleep state, where the thread is paused. So there are different states of the thread. And in this example, we are going to focus primarily on three states, which is the ready state and the running state and the completed state. So when you call the run method, the thread state is going to change to running. And whatever code you write inside this particular run method will be the logic which this particular thread is supposed to execute. Here, I'm just putting a dummy logic where I'm just printing a sysout. But definitely, if you try to create your threads, this will contain your actual business logic. For example, that fuel indicator code or for the leaderboard position code will go inside this run method. And then I'm catching an exception if there's an exception, but obviously there will not be an exception coming in because I have nothing here literally. So that's what we are doing when we are creating this thread1 class. And let's come back to the threading demo now. So to initialize a thread, or initialize might not be the right word, to run a thread, the first thing which you need to do is to initialize the class containing the run method. So I would avoid calling this class as thread because technically this is just a class. So you basically create an object of the thread just like you create the object of any other class. There's nothing new here, right? So we just say new thread1 and then we call t1.start. Now, if you observe carefully, there is no start method here. We just had a run method, but this code is still compiling fine. And I'm calling the start method here because the start method is the internal method of the thread class, which in turn is going to call the run method. So you are never going to invoke the run method directly. You just need to start the thread, which is going to change the state of the thread from ready to running. So this start method has the responsibility of changing the state to running. And the way the start method is going to do that is by calling the run method internally inside the JDK itself. From developer perspective, you just need to call the start method and that's it. The thread will start running and whatever is present in the run method will get executed. So that's the way to start the thread. Second thing, I have one more thread created here, which is the thread2 class. So in this case, when I create a thread2 class, I'm not extending it from the thread class. Rather, I'm implementing the runnable interface here. So this is a different interface available, which is a functional interface, which means it will have just one method, which is the run method. But the interesting thing is that here, when I created thread1, I said extends thread. But here, when I'm creating the second thread, I'm not using extends thread, but I'm using implements runnable. Let's understand why do we do that first of all. The reason Java provides two different ways of creating threads is because there might be a use case that you need to extend your thread2 class from some of your custom Java class. Remember, Java does not support multiple inheritance. So at a time, you can only extend this class from one class. So what if there was no runnable interface and you need to extend this thread2 from student class, let's say. So you need to do class thread2 extends student, for example. The student is not present here, but let's assume it is. So you do this, and then you also have to extend it from thread. Now, Java doesn't support multiple inheritance, and this will not work. So what would you do if you have to also create it as a thread, but also extend it from some of your parent class? You will not be able to do that. And that's the reason Java provides the implements runnable, because then you can extend it from any of your superclass of your interest, and at the same time, also implement it with runnable interface so that you can treat this class as a thread. So that's the reason Java provides two different ways of creating threads. Remember that it's a very important concept. And once you implement runnable, again, it will ask you to override the run method. So I will just put override annotation here. So once you override the run method, again, you can write whatever logic you want this particular thread to execute inside the run block. Coming back to the main class. So when you are extending from thread, the initialization is very simple, where you create the object and you call the start method on the object. But if you are creating a thread by implementing the runnable interface, the initialization of the thread is a bit different. And it's different in this particular part. On the left-hand side, you still say thread T2. Remember, you are saying thread and not thread2. This is the Java thread class. This is the JDK thread class, not your own thread class. So you say thread T2, then you say new thread, and inside the new thread, you provide your own class type. Thread2 was your own class type. So you specified your own custom thread class here inside the new thread constructor. This thread class is the JDK class. If you click on this, you will see this is from the JDK class. So that's the difference. Extending thread, simple initialization, implementing runnable interface, do the initialization like this. And after that, you call similarly the start method, which is in turn going to call the run method. So that was how you create threads differently. And now let's run this program to understand how the output looks like when we run these threads in loops. Remember, I'm initializing 10 instances of each of these threads. So in total, there would be 20 output lines. So if I go to run as Java application, I see this output here. So let's observe this output for once. So thread 1, thread 2 is running in sequence in the first time, but then you see thread 1 is running twice, and then thread 2 is running twice. Then again you see a good sequence, but again thread 2 has run twice here. Again thread 1 has run twice. If I go further down, thread 1 runs once, then again thread 2 runs twice. Thread 1 runs once, thread 2 runs once. So there is no particular order here, though based on the code which we have written, we should expect thread 1 is running from here and then thread 2 is running output from here in a sequential fashion. But we don't see the sequential fashion here. And this is the power of concurrency. This is because threads never run in sequence, they run in parallel. And which thread will execute first, you can't really predict that. So so be very careful whenever you are writing multi-threading code, because you cannot predict the sequence of execution, because threads are going to run whenever they find the idle CPU. So the key is the idle CPU. Whenever a thread finds an idle CPU, it is going to occupy that CPU and going to run its own execution. And the moment its execution finishes, the other thread will jump in and take a piece of the CPU. So whichever thread gets the idle piece of the CPU is going to execute. And that is the reason you see this randomized output. The next time you're going to run, you will see a different random order. So this time you see thread 1 ran 4 times. You did not see this in the previous execution. If you run it again, you will see again a different output. This time the thread 1 ran thrice. So every time you will run this, you will see a different sequence. There is no guarantee of order because the threads are running in parallel and they're running whenever they get the idle CPU. That's the bottom line. So this is how we are going to create threads. And remember, you cannot guarantee the sequence of the execution. So write your code accordingly and use the threads for independently running parallel threads which do not depend upon each other. And let's get started with thread synchronization in Java. So in the previous example, we saw that when we execute threads, then we can't guarantee the sequence. But it's actually technically not a problem in the example which we had a look at before, but it can become a bigger problem when two threads are trying to access the same object. Remember, object has properties and state. So what if the first thread modified the object state and the second thread is reading the state of the object? The second thread is expecting the original state, but while it was trying to read it, the other thread modified its state. So you can see this can become a big problem. For example, if you are working with a banking system and if there are two persons accessing the same account at the same time, one is depositing the money and one is withdrawing the money from the account. And if the total balance is 1,000, and if both of them deposit 500 and withdraw 500 at the same time, then who sees what? And if these are handled by two different threads, then we can't guarantee if somebody sees a 1,500 as the total sum or somebody sees a 500 as the total sum, or there can be a scenario where somebody sees 0 as the total sum. So the application can turn into really weird scenarios if two threads are trying to change the state of a particular object at the same time. And Java provides a solution of it with the concept of intrinsic locks and synchronizations. So the idea is that when a thread tries to work on a particular object, it basically takes a lock on that particular object. We also call this as an intrinsic lock or monitor lock. So it takes a lock on the object, and it means that that particular object becomes completely inaccessible to other threads in the system at that particular time. So the moment you put synchronization or you put lock on a particular object, only the thread which has taken the lock will be able to access the object, and other threads will be forbidden from accessing the object. So that's the idea behind intrinsic locks and synchronization. So that was about the brief theory of it. Now let's have a look at a practical example. So I have prepared another example for it. So here I have again created two threads, but these two threads, it's pretty much the same threads which we covered in the previous session, named as thread 1 and thread 2. One is extending thread class and other is implementing runnable. But that's same, but the interesting part is this. Both of them have a reference to a class called mathutils. If you see, thread 1 also has the reference and thread 2 also has the reference. And what the mathutils is doing here is basically you supply a number and it prints the multiples of it till 5. So for example, if you supply 2, you will get the output 2, 4, 6, 8, 10. If you supply 3, you will get the multiple of 3 up to 3 times 5. So 3, 6, 9, 12, 15. If you supply 4, you will get the outputs in the multiples of 4 till 20. So whatever number you will supply, you will get the next 5 multiples of that particular number. That's what this class is doing. And another thing, interesting thing which I've done here is this thread.sleep, which means that when you run this loop where you are printing the multiples till 5 of that number, every time you do the first multiplication, then you sleep for 400 milliseconds. And when I say sleep, it basically means the current thread is going to pause its execution for 400 milliseconds, and it is going to leave the CPU idle. And if there is another thread running currently in the system, that thread will get the share of the CPU for that 400 milliseconds. And once the 400 milliseconds is finished, the thread is going to wake up and it is again going to hunt for the idle CPU to pick up and start doing its execution. So that thread.sleep happens for 400 milliseconds at every step of this iteration in this for loop. So thread 1 is going to use this particular method of this particular class, and it is going to ask the class to print the multiples of 2, and thread 2 is also going to access the reference of the class and access the get multiples method, but this thread asks to print the multiple of 3. So thread 1 asks for printing the multiples of 2 up to 2 times 5, and thread 2 wants to print the output to multiples of 3 up to 3 times 5. So that's the basic scenario. Two threads accessing the same object, supplying different values and expecting the output. So if I run this demo as is without any change, here I'm just initializing the mathutils class, initializing two threads, and then calling the start only once. So if I run this particular program, I see this strange output that even when I said t1.start first, so t1 was holding the multiple of 2, remember, but I still get 3 first, then 2, then 4, 6. So multiples of 2 gets executed here, but then the other thread takes the CPU and it starts running its own multiples outputs. And you see 9 printing first, and then 6 gets printed, then 12, then 8, then 15, and then 10 at very last. So the output looks very random. It would have been nicer if I could have seen 2, 4, 6, 8, 10 once, and then 3, 6, 9, 12, 15 once. If I see them in different sections, in different sequences, that would have been so nice, because then I know which thread is running when and when that particular thread is working on the object. So I'm just trying to replicate the same scenario where two threads are accessing the same object at the same time, but they are executing the object randomly. They're changing the state of the object randomly here. So how do we fix this? To fix this, we can we have this get multiples method, which is the bone of contention here. This is the method which is being randomly accessed. So what I can do here, that I can put synchronized keyword in front of the method. So once you put the synchronized keyword in front of the method which is being accessed by multiple threads at the same time, this whole method gets synchronized now. What this means, that one thread will be execute this method at once. There will never be a scenario where two threads are simultaneously executing this get multiples method, or even getting a hold of this get multiples method at the same time. There would be only one thread at a time executing this method. So if I put the synchronized here, and if I rerun this example, you see I get a more streamlined output. If you notice, everything is running like clockwork, where first the thread 1 gets executed. So I get 2, 4, 6, 8, 10, really well printed. And then the second thread starts, which says 3, 6, 9, 12, 15. The reason I get this output is because when I did t1.start, it immediately went to execute the get multiples method, but it saw synchronized there. So it took a lock on the method. And even when the t2.start might have got executed, maybe milliseconds after that or nanoseconds after that, it still could not get hold of the get multiples method, because thread 1 occupied this particular method. It took a lock on this particular method due to the synchronized keyword. So that's the power of synchronized keyword, that you can take a lock on a particular method if you put it in front of the method. Now there can be scenarios that you do not want to lock the whole method. You still want two different threads to access the method, but there can be very few lines of code inside the method which is thread sensitive code. Now, how do you spot thread sensitive code? There is no magic bullet, there's no silver bullet for it, and it comes with experience. So you need to have that experience to know which is the thread sensitive code which can create problems if two threads run that code at the same time. So the moment you have spotted that code, and if you don't want to lock the whole method, you can lock the exact lines of code by putting the synchronized block. So if I remove this and I enable this particular part, so what I'm doing, that I know that this is the code which is exactly causing the problem, which is creating this random output. So what I can do, that I can put the synchronized keyword right before the block of the code starts, which is thread sensitive. And the way you do that is you write synchronized and you supply this, which means whoever has the whoever has the object of the math utils, that whole object gets logged for this particular block of code. So whoever has the math utils object takes the lock on the object for this particular block of code. If there were some other code which was written in the get multiples method before the synchronized block or after the synchronized block, that block can be accessed by multiple threads at the same time. But this code will only be accessible to one thread at a time. There will never be a concurrent access to the synchronized block. That's the power of synchronized block, and it will work the exact same way. So to show you, if I run this particular program, I still get the output in the same streamlined way, where first the multiples of 2 get printed and then the multiples of 3 get printed. So that's how you can actually use synchronized methods or synchronized block to make sure that one thread is accessing a sensitive object at a time, and there will never be a scenario that two threads are mutating the same object at the same time. Again, like I said, be very, very cautious of when you use synchronized blocks and when you use threads, because threads have unpredictable execution cycle, execution sequence basically, and synchronized blocks also have problems if you have thousands and thousands of threads running in your application, and if you put synchronized on a particular method, your application may face severe performance issues because all of the threads will be executing that method in a sequence. Imagine you put this onto a huge application or a huge e-commerce application or a news website. It is going to create serious performance issues. So be very cautious of how and when you use synchronized method. And the key to that is to have that developer DNA to spot the code which is causing this problem, which might be thread sensitive. And maybe you might need to change the code itself. You might not need to go into the multi-threading scenario, and you might be able to fix it without using the threading or synchronized concept. It completely depends. But always have a good trade-off of when to use the synchronized methods and synchronized blocks. And let's get started with auto boxing and unboxing in Java. So if you remember, in the very first sessions, I talked about the primitive data types, and then later on, we talked about the objects. For example, we had the int data type, but there later we also saw an integer data type, which can also pretty much do the exact same work which int data type was doing. And we saw the similar kind of experience for the float data type and the float class, double data type and the double class, char data type and the character class, and so on and so forth. So Java provides an easy way to convert a int data type variable into an integer data type variable, and also back from integer data type variable to an int primitive data type variable. Now you might be wondering why we need that. There would be scenarios, for example, if you had an int array as a primitive int array, and if you want to store that into a collection, now collection can only be of type of objects. It cannot be a type of primitive data type. So you might need to convert this int primitive data type array into an integer object collection. So you need to do this conversion of int data type to integer data type. And there would be cases where you might need to do vice versa. So that's the basic idea about auto boxing and unboxing. So when we talk about the definition, you can see auto boxing is the automatic conversion that the Java compiler makes between the primitive and their corresponding object wrapper classes. So whenever you are converting a primitive data type to an object class, this is called auto boxing. And when you do the reverse, it is called auto unboxing or simply unboxing. So let's understand this with the help of an example now. So I'm just going to open an example about auto boxing and unboxing so that we can have a look at it. And here it is. I've created a class which is called auto boxing demo. It has a public static void main method, and inside the method, I'm first simply declaring an int data type variable I with the value 10. Then if I need to auto box this, if I need to convert this primitive value into an integer object wrapper class or an integer class type, then I need to write the code like this, which says integer dot value of, and then you can supply the primitive data type value, and the output of it will be of type integer class. So you get an integer object, and then you can print the object to check if it is successfully doing the auto boxing or not. Similarly, doing the other way around, once I have converted this into an integer object, let's convert this back to a primitive data type. So from integer object, I'm converting this back into the primitive data type. And you see here, it's a simple assignment. I just have to assign the object to the primitive data type, and that's it. I can do the same for a character object and a char data type. So first I create a character object, char obj, and then if I have to unbox it, I can simply assign this char obj to a char primitive data type ch, and that would be it. So you can do the similar drill for any other primitive to object wrapper conversion. Let's say you want to convert a float data type to a float class, or you want to convert a double data type to a double class, then whichever primitive data type has an object wrapper class, you can do the auto boxing and auto unboxing like this. Remember, whenever you have to do autobox, it means you're going from primitive to object. And for that, you need to call the value of method. For example, if you were converting a double primitive to a double object class, double object type basically, then you are going to call double dot value of. And similarly, the same kind of behavior will be seen for other object wrapper classes as well. So for auto boxing, you call the value of, and for auto unboxing, you literally just assign this to a primitive, and the object wrapper class value will automatically be assigned to the primitive data type. So let's run this now and observe the output. So I had the int I equal to 10. Then I wanted to convert this primitive into the object wrapper. And the way I can do that is by calling the value of method and supplying the primitive data types value. So that's why I'm doing it. That's what I'm doing here. And this IOBJ should get the 10 value now, which I can see if I print the sys out, and if I just print the integer object altogether, I get the value 10. So this concludes that I've successfully am able to auto box the primitive into an integer object. Now looking at auto unbox, like I said, you simply can assign the object wrapper to the primitive data type variable, and that should work as is. And that's why at line 15, we get this output which says value of I1 is 10. Similarly, when we try to auto box the character object, so I have created a character object here, and then I want to unbox this back into a simple char data type ch. So when I print ch, I get the same value, and when I print the char obj, I again get the same value. Remember, the reason I've put this as auto box is because this by default is being stored into a char data type. I can also write it like this. For example, I can say char x equal to a, and then I can refer here as character dot value of x. This will pretty much have the same impact or the same effect which I had just now. It is going to print the exact same output. If I rerun this program, I'm going to get the exact same output. So this basically concludes our understanding that you can use the auto boxing and auto unboxing pretty easily whenever you have a scenario where you want to convert the primitive data types to the object wrapper classes, or you want to convert the object wrapper classes back to the primitive data types. And that's all I'm going to cover in this particular session.
And with that, we have come to the end of this tutorial. If you guys feel that we have missed out on some important topics that we were supposed to cover in this tutorial, then please feel free to drop them down in the comment section below, and we'll have your questions answered. If you guys like this video, then do give it a thumbs up. Please comment your doubts below, share it with your friends, and don't forget to subscribe SimpliCode. Thank you.